Let's do this thing. Just gotta tweet out the link here, share the link online. We will see if anybody joins right away. Last time it was pretty quick. Let's do a quick audio check. Yeah, it's working. So once a couple people are online, I will endeavor to explain what the project is for the night. I see a few people are already online here. Hi Asaf, hi Karifa, hi Decaf Smurf, good to have you. Let me, man, I never trust Twitch to actually tell me if people are chatting anymore. It's just been so unreliable for me. There was like an entire stream where the chat just never updated. And I missed a bunch of messages and like just went the whole thing assuming that like, well, I'm streaming, I might as well keep up some commentary even though nobody's actually engaging. I hope that will not be the case this time around. So this should be a fun project that I have for the evening. Just like a one-off thing, not anything that I've been, you know, it's not a long project and it's probably not going to be anything serious, but just a fun experiment with regular expressions based on stuff that I've been annoyed with over the past day, basically. But first, I actually do have to share the link to this stream. Go to the Handmade Network Discord, over to our streaming corner here. I should really update my channel graphics and things at some point. But hey, let's open that up, see if the viewer lists are any better. I might just refresh the dashboard. I'm so paranoid. So yeah, I just want to give it a few minutes for people to show up and stuff. If I've missed any messages, sorry, it's just because I'm refreshing all the time. In the meantime, I'm going to be just making sure that my Python environment is set up because Python is going to be the tool of choice for tonight. What am I going to call this thing? I don't even know. It's all a mystery. Let's see. Maybe I'll save that for the actual stream. The point is, at least, that I do have Python working, and I've got my little bash emulator, so I'm in my happy place. Import anti-gravity. Working like a charm. Python works. And it makes me very happy that that Easter egg exists. It's a good test just to make sure everything's working as expected. I wonder what version they added that in. I mean, when did that XKCD even come out? It's a long time ago at this point. Does Python have ranges? I can't even remember. It does. Just some warm-up exercises just for fun here. X for x in that range if x on 2 is equal to 0, just to get the even numbers. I love that Python has these features. Like, I've used other scripting languages that don't have these nice list manipulation things, and it's just not as much fun. Hey, Jesse. Tonight's going to be Python, so I'm just warming up a little. I should probably, like, oh, I can zoom in. What do you know? That's nice. Oh, weird that you can actually see OBS in the background of this thing because of my Commander theme. Is that going to look weird? That's going to make the compression weird on Twitch. How do I change this? How does this work? Monokai is great for the color scheme. That's what I use in general. But how do I make it not opaque? Where would that be? Background. Huh. Whoop. We're gonna forget I ever changed that. This is weird. How do I actually change the background transparency, I wonder? My goodness. Every emote. So I mean, I wouldn't be surprised if there's some stuff. So that just changed the colors to the Windows stuff, but it didn't actually change the background transparency. Oh, transparency. Goodbye. I don't want transparency. There we go. So, no transparency, we're good. Save settings. Thank you, Commander. Ha! Yeah, you saw it before I did. I would have expected it, like, I don't think of transparency as a feature. I think of it as the appearance of it, so it's a little bit odd that they've put it under. Well, okay. You've got general appearance and fonts and a bunch of other stuff that looks like, you know, your appearance. And then you've got features, which has colors and transparency. I don't quite understand that settings design, but whatever. Now it's just highlighting things weird. Can you do that? Aw, man. You can't do else in Python list comprehensions? Surely you can do else in Python list comprehension. Oh, I suppose you would have to do that up front. X if x mod 2 else 0 for x in range 0 to 100 if no. Yeah, right. So that's what you have to do. Because I suppose that makes sense. Your base set has to have all the elements in it, and then you can apply some transformations on that. Okay, before it gets going, I'm gonna see if I can do FizzBuzz in a single Python list comprehension. So what is FizzBuzz typically again? I mean, it's just sort of a modulo thing, right? FizzBuzz. If it's multiples of 3, it's fizz. If it's multiples of 5, it's buzz. Okay, here we go. So let's see. Fizz if x mod 3 equals 0, else buzz if x mod. No, I have to do FizzBuzz first. FizzBuzz if x mod 3 and x mod 5, else fizz if x mod 3, else buzz if x mod 5. Oops, I missed a quote in there. else x for x in range 0 to 100. 0? Oh, this isn't right. Shoot. Oh no, I left my banner up. Yeah, thanks for catching that. Okay, well, this didn't quite work. Clearly, I don't know how the precedence works in this particular situation. So, let's try that again. Fizzbuzz if x mod 3. I'm just going to be paranoid about it. X mod 3 and x mod 5. Else fizz if x mod 3. Else buzz if x mod 5. Oh, was I not doing equals 0 the whole time? That was probably my issue. Let's see if that was my issue. I just did x mod 3 and x mod 5 as though that would... Oh, I did like inverse fizzbuzz. Because it was seeing if it was truthy, which would mean it's not 0. That might be the issue. Fizz buzz, 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, fizz. It works. Python's fun. All right. Well, with fizzbuzz out of the way, I've proved that I'm a real Python programmer, and I can get to what I actually want to do on this stream tonight. So, basically, I've been working on a new BB code parser for my favorite site on the internet, the Handmade Network. I'm on the technical staff for the network now, and we've been, it's like an all new tech staff. We've been learning the code base of the site and starting to get into it. And one thing that we found is that the forums, which, one moment. One moment. How do I do my webcam here? I want my webcam still visible. Video capture device, add webcam. Thank you, good. I just gotta log in first. Log in. Log in, log in, log in. Okay, back to the scene. So, the Handmade Network has this forum system. These forums use BB code, like a form of BB code that is sort of handwritten. It's got all these different tags and things in it, but one thing that we found is actually that the previous BB code parser was pretty complicated, a little bit hard to iterate on, bulkier than it needed to be, and so we decided, well, this will be kind of a fun project, good introduction, good, easier, but kind of substantial and helpful change to the network code base. Let's make a new BB code parser. As part of that, though, I got into some regular expressions in Python and ran into a couple snags with regular expressions that were really frustrating to me. So I'm going to go into those a little bit, just sort of to clarify what I'm doing here. Oh, perfect. We've got the network code base up, so you can actually use my actual regular expressions as an example. And I will pull up debugX so that I can sort of visualize what was going on in these things for clarity's sake. So, as part of this new parser, we've got some regular expressions to try and detect tags, and tags would look something like, if you do like a quote, it would be like quote, and then you can put in the username of the person you're quoting, and then you can have some content in here that is actually styled and whatever, and you want that all to work, and then end quote. So it's sort of, that HTML-like structure. Tags sort of can have arguments where you could do like, link to another post ID as well. So, and you could have any number of arbitrary arguments to that thing. And anyway, part of the parsing process was that we have these regular expressions in there. In particular, we've got a regular expression for an argument, and we have a regular expression for a tag. And so here's the thing. First of all, let's take a look at the regular expression for an argument, which is spaced out this way because Python has a flag that lets me do that. Basically, if we paste that in, we get a structure that looks like this. Basically, we've got a name, which is just some string of just letters. We've got maybe white space, an equal sign, maybe white space, and then a single quoted value, a double quoted value, or nothing. And then we can, actually, then that's the end of it. So, and you can also just have sort of a bare argument where you just like have it there and it doesn't really have a value. You could treat that as just sort of a truthy thing. And so in that case, you would just sort of skip over it because that whole group in here is optional. So if we put in an example tag, maybe we'll do that quote I did from before. Quote and post is 1, 2, 3. So you can see you can do it like with or without quotes. You can put spaces in and stuff, and it should still recognize it. So like this is the a fairly simple regular expression, albeit with a lot of extra Python-y syntax, but a pretty simple regular expression that we're using to detect these arguments. So then the thing is like, well, a tag. Well, what's a tag? A tag is basically a bunch of arguments with brackets around them, right? But we really need to be able to pick out a tag as well. So in kind of the parsing process, we needed a thing for that. And so the thing was, well, it would be really nice to be able to embed the regular expression for an argument straight into the regular expression for a tag. Unfortunately, that doesn't end up being very easy. Because, like, here's the problem, is that, like, if we tried to just write that out from scratch, let's say, first of all, that I start with the original regular expression, and I'll just sort of strip out the extra Python stuff, or I'll collapse it down onto one line so that you can actually sort of copy-paste it into a place without too much hassle. Pardon me while I just delete my way through this whole thing. Oops. Delete that, and we've got ourselves down to a basic, so this is the same regular expression now. But unfortunately, like, actually putting this into a tag is annoying because the regular expression for a tag is basically, we need at least one argument. Let's see, why, I'm trying to remember exactly how this regular expression is set up. So let me kind of copy this in place below and then we'll update it. Where basically, wherever you see re, arg, s here, that is me basically just pasting in the regular expression string, the regular expression for an argument. So basically, it looks like an opening bracket, maybe white space, definitely one argument, and then you want this sort of spacing to get like white space in there. So this is the weird part of the structure, is that you want to have an opening brace or an opening bracket, optional white space, some argument, and then 0 or more other arguments, but there has to be mandatory white space in there anymore. It's not optional anymore. So you can't just like reapply this rule, and we can't just make white space mandatory everywhere, because then you would have to put a space after the opening thing, and that wouldn't make sense. So unfortunately, the regular expression for the argument ends up showing up in there twice, which is really bulky. And furthermore, if we actually do this replacement and put this regular expression for an argument in both places, first of all, it's incomprehensibly wrong, and second of all, it doesn't actually work, because the original regular expression has these named groups in it. So this thing that I've highlighted here, and I'll zoom in actually so that you can see that better on stream. This group with a question mark and P in brackets and a name, like that designates a named group in Python, which makes your code a lot easier, because when it matches, then you can just extract the information from the regular expression by that name. So you don't actually have to count groups and figure out which index it is, which gets really confusing. But names have to be unique in a regular expression, which means we can't just reuse this thing twice. It just doesn't work that way. And so then the other problem is then like, well, I made this strip names function, which actually does a substitution on another regular expression to convert named groups to normal groups so you can embed them into another regular expression. But then that broke a thing where I was using named back references, and it's like you can't use all the regular expression features if you want to combine them in this way. And furthermore, what even is this? Like, you look at this and go, like, what on earth is going on? Like, even if this was, you know, a bunch of different names so that you could actually compile it, now your regular expression is pretty gnarly. You certainly like would have a very hard time debugging this, like just understanding it if you run across this in somebody's code base. You know, what would you even do just looking at this? It's really helpful to have like this railroad diagram basically. But this is pretty complicated. Not my favorite thing. Looks like someone forgot to null terminate a string. Yeah, it kind of does. So my idea, also inspired by some Jonathan Blow tweets where he was tweeting about, like, has anybody made it easier to use regular expressions because they're ridiculous? I actually want to see if I can find that tweet. Jonathan Blow, Twitter, regular expressions. No? Regex? No? Oh well. I remember seeing tweets by him a long time ago about, like, you know, asking about such things because he needed to do a string pattern matching kind of thing. But it's like, I've gotten so familiar with regular expressions over time that I've kind of forgotten how gnarly they are to learn and just to use. And like, I depend on debugX as a tool for just understanding and, you know, debugging regular expressions for myself, because it's like, even I who know the syntax for them still find them pretty hard to work with. And so the idea is, well, why not try to make sort of a nicer way of building regular expressions and a little bit of an interface around them that would let you compose them. And it's basically just using, it's building a regular expression and just using, in this case, Python's regular expression parser, you know, and actually its regular expression engine behind the scenes. But, you know, just trying to provide a little bit of extra functionality that might be really helpful and make it sort of self-documenting in your code. So that's what we're going to try to, oops, how did I open Perforce? I was just trying to zoom out. Okay, whatever. So the project for tonight is to experiment with a little regular expression library. Might not really go anywhere, but I thought it might be fun. So let's get this thing open. I'm going to, first of all, make a little directory for it here. What am I going to call this? I've got a bunch of projects floating around in here. I'll go into my own like GitHub library, and what am I going to call this? Pretty regular expressions, nice regular expressions. Stream? What do I call a library that makes regular expressions easier to work with? I am open to suggestions here. Naming things is so hard, especially when you have no idea what you're about to make. This is just going to be pretty reg. What if it could be a play on like regular expressions are just like regular in the sense of normal, boring expressions. These are just plain old regular expressions. But these are like fancy expressions. These are not fancy though. They're friendly. Like the yeah, the regular company. Exquisite. Now we're getting somewhere. XQuex, exquisite expressions. I think XQuex is a pretty good name. That's untypable. It's all like the most awkward letters. on my left hand. But you know what? I'm rolling with it for the sake of the stream. That folder's getting renamed later, but this is too good not to do. Okay, so xquex pi. I can't type it. This was a mistake. Anyway, though, let's open up Sublime here, and let's get this thing going. First of all, I'm just gonna throw a little shebang at the beginning so that I can run this straight from the command line. And I'm gonna do my like if, let's see, if name equals main. Is this how Python works? I never remember exactly what that syntax is, but we will find out here. That wasn't it. Is it that? That's what it is. Double underscores on both of them. Okay. So this I can just use for my sort of testing of it. So the idea basically is that you could do something like this. Rather than if you wanted to match something like that tag, and I'm just going to sort of put that example right here. Again, for future reference, it would be really nice to be able to define a regular expression like the regular expression for an argument is something like some function like exactly these characters, maybe we would call it exactly, and it would be like just a single bracket. No, we're just doing for an argument, so it would be something like chars, and then you can just provide sort of that regular expression string where you do like A through Z, just to get all, you know, and maybe underscore and dash if we wanted. You know, those are the characters you're going to allow, and then you can do like wrap that in a function that's like one or more of these characters. So like, you know, each of these basically mapping to a common part of a regular expression that you'd be used to, but that can kind of be chained and composed together to actually form a regular expression eventually. Like it'll all just return a regular expression that you can use. Or rather, it might be a little bit of a wrapper so that I can do like more stuff with names, but this is sort of the idea. So you could do like one or more of those, and then you can do like then, and then another thing, and then chain together some thens, and you know, sort of like have this nice syntax for forming it. So if we were going to, I'm just going to write out all the usage code, and then we'll try implementing it, I guess. So we would have one or more blanket expressions, maybe. Then, I mean, maybe you could just provide a string to a lot of these things, right? Rather than do like the word exactly, maybe you can just provide a string. So then an equals. Ooh, here's what we can do. We can do like 0 or more, and then do white space. I guess we'll do Python raw strings and all of this stuff just to make sure that we're getting exactly what we expect, especially with regards to backslashes and stuff, because it's wrapped. Burrito expressions. So it'd be like one or more of these characters, 0 or more white space characters. I gotta apparently do these thens around it as I'm doing it now. The then might get a little bit verbose, but we'll see. I want to write out a full example in kind of this syntax, and then I can iterate on what I think of it. 0 or more white space characters, and then one of, and now you can provide like a list of regular expressions, or of these regular expression wrappers to deal with. So then it would be like, now we can match, as in our example before, you can have either single quoted, double quoted, or no quotes values for these things. And so then maybe that would be like, you know, we have sort of a sub-regular expression for this, which is to say, oh shoot, I need a wrapper around string so that I can get my methods going. We'll see about that. Exactly, exactly a single quote, then a, let's see, what was my actual regular expression? I should really bring over my my other regular expressions that I have that for comparison. We're just gonna put these up here so that I can compare. Basically, we have, right, just a non-greedy anything that goes until it sees another single quote. So that'll just eat up anything up until it sees a quote, which is a pretty sensible behavior. So then we can do like 0 or more of just anything. How do I do the non-greedy part? I mean, I could just name it non-greedy, which would probably be fine, or I could try to have a non-greedy wrapper around it, but that seems dicey because the question mark is sort of overloaded syntax in regular expressions. 0 or more, not greedy of anything, then exactly. I'm gonna stick with the exactly syntax. It's gonna be a little bit verbose for now, at least, but we'll see. Burrito, happy, yes. Maybe I like that better than ikuquex. At least it's possible to say and type. And then exactly, again, a single quote. So that would end it. So that would form, I mean, you can see how this on its own would return kind of a full regular expression wrapper, right? It's like a single quote, the 0 or more, and then another ending single quote, or it could be that again, but with double quotes, and I'm going to, whoa, thank you Sublime for understanding exactly what I wanted to do when typing these quotes. But, you know, exactly double quotes, 0 or more of those again, or exactly, what is it? Actually, this one's not, we don't have an exactly on it. We basically are just looking for not characters. Basically, we're looking for anything that's not backslash, or anything that's not white space or a closing bracket. We'll continue this argument. So, which means that you can actually have quotes in one of these things if you like prefix it with any non-white space character that isn't a quote. It's kind of interesting, but it seems fine to me. So we'll do basically not characters, and then again you can just specify like white space and close bracket. And basically we want one or more of those. One or more of not those characters. Oh, and then the entire thing is, let's see, actually this entire last part is all in a maybe. See, this is where you need exactly. Clearly, you actually need to have the word exactly around just raw strings. Oh, that's a good point. I don't know. I just started typing camel case because that's what I started doing. That's what I typically use at work, and so it's just sort of a habit. But you're right, it's not very Pythonic. And it's not very readable as I look at it now. Well, no harm done. One or more gets replaced with one or more. Oh yeah, I have work. Tons of it. 0 or more gets replaced with 0 or more. Yeah, that actually does it. I should be able to pretty easily like break this into different lines or whatever if I really wanted to. Although it is Python, so line breaks can be a little bit trickier, but I'm confident that I could make it work. So let's see. So one or more of those characters, then 0 or more white space. Oops, I put the maybe in the wrong place. The maybe was supposed to go before that initial white space. So let's see, maybe 0 or more of those, then exactly that, then 0 more of those. I get the sense that see, I'm already getting lost in this. The hope is that this would be self-documenting, like a self-documenting way of building up a regular expression. But this is getting pretty verbose in a way that I'm not super happy with. And it's probably just that you want like more concise method names because building up a complex pattern is going to require a lot of these. Also, having to do .then is not my favorite thing, but we'll see. So I just want to at least type out this example. So basically, we're matching this thing. If userman, if you just came into the stream here, basically we've got this thing, and basically we're writing the regular expression for just one of these arguments right now, like name equals value, and the value can be either single quoted, double quoted, or neither. You can have arbitrary white space around them, around the equal sign in the middle. So that's where we're getting this one or more here is the name. I haven't even put names in it, so that's the other thing that I have to add once this is a little more sorted. So you'll have like one or more of these characters for the name. You'll have maybe some white space characters. Oh, 0 or more doesn't have to be. Oh, yeah, the maybe is around the whole thing. So it would be like maybe 0 or more white space characters, then the equal sign, then 0 or more white space characters again, which is just mapping to this thing. Then we have our value. So that's just, we're up through the equal sign and the white space now. And then we would have one of these things where we have exactly a single quote, 0 or more. Oh, that's hilarious. Not greedy. Of anything, just to capture through until we get to a, until that closing quote, and then exactly that closing quote. Same for double quotes, and then for the bare case, we have one or more characters that are not white space or a closed bracket. So that just ensures that you, that basically just ensures that you can pick up an argument that's just written in bare form like this. And that actually would let you have quotes in it. Like you could do that, and it would actually recognize that since there's no white space in there, which is interesting, but it should be fine. So let's break this out back to what it was. So this is now incomprehensible. Yeah. So this is all a brainstorming sort of design process right now. So clearly there must be a nicer way to do this. I like that you can structure it, but I haven't even put names in it yet. If I want to do like a named group or something, then this is just going to be even worse because I'm going to have to like compose this yet again where like the one or more of those chars would be name, and then this would be, actually the name of the tag. I'm going to call it tag name just for clarity, and then one or more of those. Right, and like this is crazy. The thing is, I mean, yeah, it's sort of a complex regex pattern, but not that complex a regex pattern is the problem. You know, like, this is not actually so bad. You look at this thing and, like, if you go back to my little debugx thing, ignoring how I pasted everything together into the same regular expression, if we go back to before I did that and before I took all the white space out of it, like, this is not even following that many paths. It's like just this, that part's optional, maybe white space, equal sign, maybe white space, and then 3 branches that are pretty simple. Like, it's not actually that complex. The regular expression doesn't end up being so big. It's still the case that when it's all consolidated down into a single line, it's kind of complicated, but at least, you know, when you work through it, it's not so bad. I really like the concept of it being self-documenting in your code, but this is too bulky. You could do, like, for exactly, you could just do E maybe. For, you know, I don't really like having all the thens in there. It would probably be nicer to just do a list rather than all the method chaining. So maybe that's the first place I really start. After all, kind of the reason I needed exactly was so that I could do method chaining with then. So that would kind of be 2 birds with 1 stone. Let's take another stab at this. So we'll just sort of comment that out for now and try again. So basically, I probably need a little bit of a wrapper function to start things off, where it's like, make a regular expression, and then we can start giving it a list of tokens rather than doing and then, and then, and then, and then, and then. So then we could do maybe like name. I mean, I think name is a sensible thing to make a named group, right? And then you can have maybe another regular expression thing where it's just make a regular expression out of, I mean, heck, you wouldn't even really need to do the like chars thing because that's an easy enough syntax to type out. This isn't necessarily supposed to completely obfuscate regular expressions. It's just supposed to make them easier to sort of build together. So maybe you don't even need to have the chars thing. You could just do a through z underscore dash for the, you know, the name of the tag, and that would suffice. You do raw strings though so that it actually understands it's a regular expression. We do want the 1 or more. Maybe it's okay actually to let us just do this. Right, we're just sort of encapsulating the bits and pieces of a regular expression into a larger structure that's easier to comprehend. So we have that, and then we have probably, so then we get into like optionally the argument, because the other thing I forgot to mention that you can just do like an argument on its own, like that's also considered valid. So this is where the next part of it after the name is all technically optional. So now we can throw this into a maybe, which I still like. That's a concise name to explain what's going on. So then we would have, you know, at this point it would be pretty easy to just do like, again, raw strings. Just do that equal sign bit of it, and then get into our arguments where we can do like 1 of, and the reason I'm doing the 1 of and stuff is basically because I want to have, I'm going to have better support for names and back references, and one of the goals for this thing is to be able to compose regular expressions into larger ones and not have names stomp all over each other like they normally do. So that's part of why I have this extra structure. So we're going to do, again, just 1 of, and this is going to be the single quoted value where you would just have a single quote, the single quoted value, where this would be name, single quoted value, and then, you know, we actually capture that inner part. And then again, we have that closing quote. I suppose this has to be make in all of these cases. Make that little regular expression bit, make this regular expression bit. I'm actually just going to copy paste this because it's just the double quote difference again. This is going to be double quoted value. And then we have one more, which is simply the bare value here, which is going to be, again, a named group bare value. And then the regular expression for that is not a white space or a closed bracket. Oh, and plus. So that is definitely approaching a structure I like a lot more, right? And this should be equivalent. I neglected to put the list into this thing, so that wouldn't have really worked. But this seems better. I might not actually need make for this one. Probably name would return a regular expression wrapper on its own, whatever I'm going to call that thing, so that could kind of just be that. Make, I guess you just need if you need a bunch of things chained together, which often you do. I don't know, thoughts on this? Does this seem like a reasonable way to do it? This approach without method chaining definitely feels better to me. Not the least of which because I don't have to do so much object-oriented method type stuff, but also because it's starting to match the sort of intuitive structure that I laid out up here, but it wouldn't produce a regular expression with all the white space in it and stuff. So I'm going to have a wrapper class of some kind, because there's going to be a little more eventually than just creating a plain old regular expression. Because as I was explaining when the stream started, you can see from, this is based on actual regular expression work that I was doing today. I wanted to build up a tag, which has these brackets around it, from these arguments, which we've made the regular expression for here. And a tag is basically like a little bit different, and it involves expressions, right? And like I want to capture the whole thing, which means I kind of need to be able to accurately recognize the arguments in the middle of it. Which is basically the syntax for a tag goes open bracket, maybe white space, at least one argument. At that point, it could just end with maybe white space, or it could go on to a bunch of white space separated further arguments. And because of the positions of white space, you actually kind of need the regular expression for an argument in there twice. And if you try to just add, like concatenate everything together and add the regular expression into the middle of that string like this, like that kind of works as long as you parenthesize it to avoid things sort of leaking out. But since these are using named groups and you include the same regular expression twice, the names stomp on each other and you can't access that stuff anymore. Like it's really difficult to actually compose them. So I made this strip names function, which I haven't copied over from the actual source file. But that replaced name groups with anonymous groups so that you could add it into another regular expression. But then I tried using named back references in this one, and then that totally blew up. And so I was like, this sucks. You know, I had tried to do the quotes with just sort of a single line and a named back reference where you do like, you know, you have your quote group, which is a single quote or a double quote, and then you just do a named back reference to say another instance of whatever we matched before. but then the back references break because I swapped out all the names, but then you couldn't actually recognize this again. Like, it just started looking for the word quote because of how I had written it, and it was not ideal. So that's what prompted all this stuff. And so part of the hope for this thing is that by making sort of a wrapper around it, I can do something more intelligent with those names. If I see multiple instances of the same name within the same regular expression, I can like name them with indexes or something so that you can actually sort of pull out into a list all of the matches of that named group throughout the entire regular expression, which could actually be a pretty convenient way of accessing all of that. So I want to make them composable. But to do that, I need a little more info about what's going into it. And I just want to make them easier to work with. So I'm sort of seeing all of these functions, make, name, maybe, one of. All of these are returning the same sort of regular expression wrapper class that contains just a little bit of that extra information. And each of these functions, I think, could take like, tell you what. I don't think you need make in a lot of cases. I think I can have all of these functions sort of universally recognize a plain old string, a list of stuff, or another regular expression object as regular expression objects. Like, I can have a make function that takes one of those things. Make takes like a string or a list or a wrapper object and makes a wrapper object. Like, it would sort of just be a catch-all. But then I could just call that on anything in the list or anything that's passed to anything and get a wrapper out of it and use that to build up like a full wrapper, you know, an entire thing made of these little wrappers. And then it'll eventually sort of render into a proper regular expression. So any objections to this design, or can I start implementing it? This feels good enough to start for me. I'm going to actually delete these redundant makes. That's kind of the point I was trying to get to, is that I can just have a list of lists and it'll sort of interpret these lists as regular expression things. That's one positive vote from Userman. That's good enough for me. I'm going to start implementing this. Oh, wow, I've actually got a bunch of viewers right now. Hey, everybody. Banana, Nan, Cog Whistle, Commander Root, Matmon Gaming, Slow Cool. Thanks for hanging out, everybody. Yeah, it'll probably change. But I'm real glad I sat down to write some usage stuff first before I wrote the implementation for this mess. Sort of dog food testing your design before it's actually implemented can be a really useful thing sometimes. So let's get to it. I'm gonna start implementing this by starting out with just a little wrapper class, which is just going to kind of be a dummy right now. I just need it defined. I'll add data to it as I find that I need to add data to it. So then we're going to define make. And make is going to take, you know, sort of a regex-like object, whether that's a string or a list that's going to be sort of bundled into one regular expression or a wrapper. Yeah, perfect bug-free program. Can't have bugs in a no-op. So make is effectively just going to, actually, what I should call this is wrap. Because that is what it's doing. It's producing a wrapper. Those are the only two instances of it, so that's convenient. Wrap, or a regex-like thing. So if, let's see, if is instance, that's right, of regex like and wrapper. So if the regex like thing is a wrapper, just return the regex like thing. We don't need to wrap it at all. I will check out that link in just a second after I'm done kind of typing this out. If it's a list, I don't actually know how to check in Python if it's a list. I know Python's supposed to be all duck typey. We're Googling Python check if variable is list. So that's to check if it's a string. I didn't ask if it was a string. Is list? Is tuple? Holy cow. Is that a thing? Oh, type of, huh. Yeah. Oh, I didn't know that's how Python works. If it's sized instead. Yeah, see, that's the thing, is like, you know, maybe you want to provide it with something that isn't just a list, but it's still iterable in the same sense. So what would that actually look like? I'm a little bit new to Python, but still wanted to make this in Python just because I'm really enjoying Python right now. From typing, import sized. So then if is instance of regex like and sized. Well, so in this case and the string case, I guess I have to sort of do the wrapping logic. So I could either have an init on the wrapper that takes something, or I could sort of keep wrapper like a really dumb class and just sort of do the work in the wrap function. So this is a good chance to think about what the data of a wrapper actually looks like. I'm kind of thinking that it's effectively a list of other wrappers or whatever. Good to know about the speed stuff. As a sort of experimental fun project, I'm not too concerned for this one, thankfully. I know having like a lot of is instance stuff in Python is not very Pythonic. In this case, I don't know what else you would really do. I want this thing to have a list. So basically, I am going to have an init that at least sort of initializes this to have its own list, because I've had some problems with shared references and things in other places. So, but I like to define the variable anyway. So we're going to do basically each wrapper has a list of wrapped things. If I really wanted to bug test myself, I could do that. Then I'll get some crashes if stuff goes wrong. So if it's sized, then what I think I'm going to do is basically we're going to do, here's the thing. Again, I could like just have you pass in a regex like, and then it could do this logic, which I kind of like. It's just a constructor, and then, you know, the logic is sort of contained there. And then wrap is just a convenience that you can throw anything at, and it will return you a wrapper and not do anything unnecessary. That works for me, I guess. Let's just return a wrapper of the regex like, and then we'll implement the init over here. So the wrap thing is going to equal an empty list, and then for thing in regex like, oh, I have to do the is instance here. If is instance regex like sized, then for thing in regex like self.wrapped.append thing, we're just going to, ooh, I could call wrap on thing. So that will make sure that I've always got wrappers around all this stuff. Another way is to just wrap the potentially error-raising code and try except and catch a specific exception related to the operation. Yeah, I try to avoid exceptions wherever I can. I know it's sometimes the sensible thing to do. I'm used to now, like in most of my day-to-day programming, I'm coding in Go, and Go doesn't, I mean, Go has panics, but the expectation is that you don't use that for sort of normal control flow stuff. Like that is for when something goes wrong, and basically you have multiple returns and you return an error type a lot of the time. That's sort of the flow I'm used to. Exceptions feel like weird inside out control flow to me, and I try to avoid it. But you know, sometimes. So we are going to, for each thing in this regex-like thing, we're going to append a wrapped version of that thing so we won't create any redundant wrappers. Otherwise, we're just going to not thing, but regex-like. We're going to append, again, the wrapped version of that regex-like thing. So if it isn't sized, then we'll just call wrap on it. Python does use exceptions as signals that an iterator has ended and such. Well, that's good to know. So use iterable in the for thing instead of sized. Is that what you mean? Got to change my import if that is the case, but that's fine. Python if is iterable. Checking for iter works on sequence types. Okay, so you would do the, yeah, I see. So you just type error on it. You know, that's probably fine. You just try to loop over it. If it doesn't work, then whatever. You know, that's okay. And that avoids me having to import a type alias and stuff. So, fine. Fine, we'll do an exception. Try for thing in regex like. I guess I can just copy paste that. Except type error, and then we'll just append the wrap version of the original thing. And hopefully that will suffice. We'll see how that plays out. The rest of the functions, I think, are going to be a little more fun. So let's say now, let's implement, Does this never end? I just realized that this is probably not going to end. This is probably an infinite recursion sort of situation, because I just realized, where on earth do I store an actual string? Because every time I construct a wrapper, I'm calling wrap, which is going to construct more wrappers on the thing. This is not, I'm overcomplicating this for sure. This is not good. What I actually need to do here is I need to have the actual regex string in the wrapper somewhere. But I kind of want to have something like where I've got my init method, and I've got like our render method that will actually return to me like a string version of that regular expression. You know, that's the thing, is that I don't want to convert everything into a string regular expression right away, because I'll lose information about names and things. So I think that I'm just actually not going to call wrap here. I'm going to accept, you know, if the thing I was passed is iterable, then I'm going to assume it's a list of stuff. And so basically I want the wrapper to store a list of either strings or other wrappers. And that should be sufficient to hold all the data I need and allow me to sort of render stuff out. And in fact, I should be able to, at least initially, like, I'm going to say that the render method for this returns like one of these Python anonymous groups, just to sort of keep things contained. And then we're going to, let's see, what is it? You do like, if I want to concat a bunch of stuff together, I could do like empty string.join. This is going to be some fun list comprehension stuff. Maybe I don't want to do this in a list comprehension. Maybe it would be more sensible to just build a string up the normal way. Result starts with that for wrap in, for thing in wrapped. Thing is a really good variable name. I could try just calling render on it, and if that fails, then it's a string, and we'll just convert that. Ooh, or this is a string function. Yeah, now I can do this as a list comprehension confidently. Plus, and then we will join together all of the strings in this list, which is I just stringify all of the items in wrapped for x in wrapped. And then we will close that off, and we'll have a thing. Fingers crossed that that works, but this should be a fairly reasonable way of converting these things into strings. So in fact, I'm going to test that briefly. I'm going to print out the result of wrapping the following regular expression. I'm just going to have like ABC and then not the letters ABC at least once. Oh, I got to do some raw strings on this. Got to do the raw strings. And then 1, 2, 3. You know, just some really simple thing that can sort of be compiled together into a regular expression. Join map string wrapped is a bit smaller. Ooh, that looks intriguing. I'll look at that in a second. But let me bounce over. I don't need that import anymore. Let me. Oh, I gotta comment all this out or it's gonna blow up in my face. Let's actually run this. Okay, name wrapped is not defined. Why would that be? It's because I didn't do self. Try again. String returned non-string. It returned none. Well, that's because I did result equals instead of returning. Try again. Hey, look at that. So that returned ABC, and then those characters, and then 1, 2, 3. And if I had wrapped again, let's see if that works. Hey, that does work. So we've got each of the sort of anonymous groups here correspond to a to one of the actual wrapper objects. And I'm putting that in there, well, basically like an anonymous group never hurts. And I figure it'll make composing easier later on if it's already groups that you can just do like one or more of this regular expression and not worry about the fact that it only applies to like the last character in that regular expression. So this is a reasonable start. What else did we have in that? Each of these is going to sort of have a different regular expression component to it. So let's do maybe, for example. So maybe just takes another list. It basically takes another regular expression thing. All of that in the middle would basically be wrapped. And then it throws a question mark on the end. So let's define that. Maybe takes another regex like and returns the result of wrap. And then we're going to provide it with a list, regex like and question mark. I think that should be all it takes. So then I could do like, rather than just wrapping this inner thing, this could be maybe. So if I want an optional non-ABC character in the middle of that, then I can do that. And oh, that rendered a little funny, didn't it? Or is that correct? That's actually fine. I'm pretty sure. Because the regex like thing I provided was just a string, it wasn't wrapped anymore. I'll maybe figure out the group stuff later on, but it appears that that basically did throw together what I want, like ignoring the group stuff, and maybe I'll just toss out the group stuff since it's kind of presumptuous of me to throw that in now. That has constructed the regular expression we want. ABC, optional non-ABC character, and then 1, 2, 3. Okay, this is some momentum. Let's try one of. So this is just going to effectively join all of these things together with pipes. And that should be easy enough. Those really, I wonder if those should be groups. We'll figure out groups later. One of, and then we'll do like regex likes, because you have to provide a list to this one. And then we're going to return pipe join, and then we're going to not string together. I don't want to convert this to a string just yet, do I? I really just want to return a list where I have pipes in the middle of everything. There's probably a really nice Python-y way to do that. How would I actually do that? You know, I just want to insert elements between all the other elements so that it would look like, you know, some wrapper and then a pipe and then some other wrapper and then a pipe and then another wrapper, and like this would be effectively what it looks like, right? Automod is so aggressive. The thing is, I don't want to be stringing things yet, you know, and that would be, I presume, doing a string join instead of actually creating just a list with some elements inserted into it. So what on earth do I do with that? I'm going to just, I mean, I know how to do it in the really iterative fashion, so I'm just going to do that for now. For I and thing in, and what is it? Items, or is it enumerate? Enumerate the regex likes. Basically, if I is greater than 0, append a pipe, and then append the thing. Return wrap result. So we'll see if that works, and if enumerate was the correct one to use, which again I don't really remember. So then we're going to convert this to a one of, and it's going to be either 1, 2, 3 or X, Y, Z, or I don't want to do those. Dollar signs are very overloaded in regular expressions. LMNOP. I don't know. That should be fine. Let's see what that does. Okay, so clearly, if I want the one of to work right, this is a case where I actually do kind of want parentheses around it, right? Because like this is not what we want, not at all. But it did mostly work. You can see that it did actually join things together, and that I couldn't remember if it was enumerate or items, but items is for a map and enumerate is for a list if I want the index. So we're going to open that up with a parenthesis. We're going to close it with a parenthesis, and then we're going to wrap the result. And that, oh wait, I wanted this to be an anonymous group so that it doesn't mess with group numberings. And there we go. So that also works. That's my one of working as expected. And name, let's do name. So we're just going to name whatever regular expression thing we have going on in here. And this is where things are going to get kind of interesting. This might be actually, maybe wrappers need to have names. I think they do. I think that's the main thing. Name, like avoiding name stopping, name smashing problems with regular expressions is one of the goals of this. So I think optionally, these things need to have a name. I guess because this is a scalar value, I can just initialize it here. Although none kind of makes sense for something that doesn't have a name. So I'm going to throw actually a name equals none property on here. And then I can just do self.name is equal to name. So I can optionally construct this thing within it. So now let's make this thing actually name it. Basically, we're just going to wrap the regex-like thing, but also set the name on it. Now, it occurs to me that wrap apparently needs to take a name as well and do some name setting stuff. Like if it has a wrapper, then it needs to set the name on it and return it back. And at this point, it's kind of like, why do I have a separate wrap function from the init function within my wrapper class? You know, like the reason that I had wrap was so that you could sort of throw something at it and it would convert it, but most of the logic ended up in there. So part of it was also that it just wouldn't create redundant wrappers, but like, who cares maybe? Like certainly redundant wrappers are kind of annoying because they might create a bunch of extra parentheses in my output or something, but that's not the end of the world. And it wouldn't be incorrect, right? It's just unnecessary groups. And they're anonymous groups, so they don't even affect group counting. Because if I wanted to actually be able to like wrap it with a name, Seems like list, but without the parentheses. What even is it then? Just white space? You're kind of right. Because it's like, I would have to do like, you know, regex like dot name equals name and then return it. This is goofy. I don't think this makes sense anymore. I think I'm going to get rid of wrap, and you're just going to call the wrapper init function directly, and that should actually be fine. We'll see how big a problem the redundant stuff becomes. I mean, you could even handle the redundant stuff here in the wrapper initialize, right? You could like copy its values over to yourself and avoid that problem completely. So this is probably a little more elegant. Somewhere I missed a call to wrap. Right here. Still working as expected. But let's actually make the name factor into it, or basically, if this thing is named, then we need to actually like return a group around it. So we're going to just name this value if name is not none, result is equal to us wrapping a named group around it. Does that not work with raw strings? Don't really need raw strings. We're not doing any backslash stuff. Format the name in there. Oh, this does have to be self.name. I guess I could just sort of, if I'm going to be in the business of formatting things, I can just do that. Format self.name and result. Result. So now we can actually use that name group down there. So this last thing is going to be name. And it occurs to me that the name function is looking pretty redundant now too, but I'll tough it out. So we'll call this the ending of whatever thing we're matching. That is going to wrap around the one of. And that did work. We've got our name group in there. But you know what I mean? It's like now, now it doesn't seem like the reason name might still be nice is just because of sort of the interface, right? Like it's kind of nice to just have a short wrap. I mean, the word wrapper is not so different from the word wrap, but I kind of like having just these really short, concise things in there because, like, I don't, you know, it's nice to be able to just call a name function that puts the name out in front of the pattern instead of having it afterward. And since it's optional, it's not like I really could put it later. You know, I couldn't put the name first in the signature or something. I'm actually going to put wrap back in, and it just returns a new wrapper of that regex-like thing. And name is just going to be effectively the same thing, but it just swaps arguments around, you know? These functions can call the constructor, that's fine, but kind of the interface of this thing is going to have just the word wrap and just the word name. So that seems to be working. What other features of regular expressions might I want in this? What other sorts of aggregate things like one of are there? You know, maybe is hardly even necessary. Like I could probably get rid of that because anywhere you call maybe, you could basically just throw a question mark at the end of your thing. But I kind of like being able to just give it an entire regular expression and say like maybe this. Likewise with one or more and that kind of thing. But we'll see. I might want to start implementing some of that name smash avoidance stuff that I was talking about, because that's really going to get to the heart of this. Because what we have so far is actually the ability to basically make this, and actually that would be a good little test, wouldn't it? Let's move this down into my main here, and let's just print that out. One of is not defined because I capitalized it differently. One of takes one positional argument, but three were given because I didn't actually make this a list by accident. Uh-oh, what? Somehow a list just snuck through on its own. Let's see, what is that list? You can see basically we've still got the brackets in there. It's actually the raw string of, oh, the maybe. Oh, yeah, because the maybe, I guess you just need to call wrapper again just to ensure that this thing, that came in. Basically, anytime you get a regex, like, you have to wrapper it in order to ensure that these values don't sneak through on you, which is okay. Again, it might end up looking a little redundant. Okay, that also didn't work. Why didn't that work? Clearly one of needs to actually construct wrappers for its things. So let's see if this output actually makes any sense. Actually, here's a test. We can just bring in this thing up here as our test string, and we can just verify that it matches. Tag is equal to that. I gotta escape these quotes in it just to make sure that it works. Oh, actually we're only matching arguments, so I'm just gonna give it I'm gonna give it a list of args as well, just sort of for testing purposes. I'm going to break each of these out into its own string that I can use for testing. Post equals 1, 2, 3. Foo equals bar. And baths. So then I can make my regular expression for arguments, and then I can for arg in args if, and I gotta import Python's regular expression again. If re.match, oh, and this would be, I gotta look up the documentation quick on this. Python regular expression, look up Python 3's documentation on it. I just don't remember exactly what the syntax is for the plain old match. Method, pattern, and then string. Yep, so the regular expression for an argument, which I'm going to convert into a string, and then the argument. If that matches, then print I want to actually see this all in one line, so I'm just going to print it together. So I'm going to print basically whether it matches or not. I'm just going to print out that true false value and leave it at that. So it matched, and it didn't match. That's interesting. Why would it not have worked? It appears to be. So basically what we're seeing here is that it matched this quoted version, the bare version, this version, but not just the standalone thing, presumably because this maybe didn't work right. Because the maybe doesn't actually put a group around it, which it probably should. Like it should actually be grouping the wrapper stuff. Now this is where that question of should a wrapper group itself comes into play, and I think yes, it should. I think in general, a wrapper should throw an anonymous group around itself just so that it recognizes things as a unit, and maybes and one or mores and anything else doesn't actually affect that outcome. So let's group this thing. Now it matches them all. And you can see that all the wrappers generate a pretty verbose regular expression, but it is one that actually matches everything we expect it to. And let's see if it matches. Let's see if it failed on some things. Like let's see if, for example, like quote does not equal delix. Fails. No, that did match. Right. Well, okay, because quote on its own is a valid. Okay, fine, fair enough. That would actually, I suppose, work in the context of our parser, which is an interesting thing to note. It finds an argument in that, at least, which, yeah, fair enough. There is an argument present in that string. What if it's something totally zany? Nope, doesn't match. Okay, good. I mean, we can see the regular expression that it's outputting here. You know, and if you look past enough of the parentheses, you'll see that we've got like our regular expression for the tag name, which we can pull out. In fact, that would actually be kind of fun to do. Like if, and now I'm going to convert that back into an if. We're going to print the tag name and then all these other groups. So we're going to print, oh, I need to do if. I'm gonna like do m is the match, and then if m exists, then we're gonna do like m.group tag name, m.group single quoted value, m.group double quoted value, and m.group bare value, just to ensure. Oops. There's a colon at the end. That's not really correct. Just to ensure that it's actually extracting values by name correctly. So we can see for the first one, and I guess if I'm in the business of printing it, then I'm going to do like arg, a colon, and then the things that we can see the original string. So if we have quote equals delix, then it pulls out quote, and the single quoted value is delix. That worked. If it's bare, then we have post, and the bare value is 1, 2, 3. If we have foo equals bar, then we have foo with a double quoted value bar, and if we have baz, then it's just baz. It's working. Great. This is actually a valid regular expression that Python understands, that can pull names out of, and that kind of thing. So this is some progress. But like I said before, one of my goals is to actually make these things composable. So now we've got presumably a regular expression wrapper that, you know, works for actually recognizing a single argument. But now let's try to make that tag. So the regular expression for a tag, as I said before, if that looks like opening bracket, optional white space, argument, and then 0 or more of these white space followed by arguments, that might be a little harder to do because of the names, and we'll get there. So the tag is going to be, we're going to wrap, we're going to start our list off here. We're going to have that opening bracket, which we have to backslash so that regular expression engines don't get very confused. We're going to have optional white space, 0 or more. We're going to have an argument, and so this is going to be, now we just provide a wrapper, right? So that's going to just be our argument. And then we can do now, and this is where we do need like some of those regular expression things, the 0 or more, 1 or more, or actually, yeah, we're gonna do that. We're gonna make a 0 or more where we provide another list, which is to say we can have, again, optional white space. No, one or more white space characters to separate arguments, and then another argument. After that, so that would get us through like argument, and then white space, argument, white space, argument, white space, argument, and now at the end we have, again, 0 or more white space characters and the closing bracket, and that is the end of our tag. If we print out the tag, what are we going to find? Invalid syntax. Why is that invalid syntax? On line 96, there's no comma. 0 or more is not defined. Well, fair enough. Suppose I should actually do that. That's effectively like maybe. It's just a different symbol at the end, namely a star. Done. I didn't actually name it anything different. 0 or more. So that got a little gnarly. Is it working? Well, mostly. We saw that basically this is the regular expression for an argument. It ends up being kind of verbose with a lot of anonymous groups in it, which we could probably stand to clean up at some point, but they don't harm anything, so for now it's okay. It does get pretty hard to read. Let's copy paste this into debugx so we can see what this actually looks like. Name must be unique is in fact the problem that we had before. So I'm just going to, for now, for the sake of output, I'm just going to make that a string, so it'll be significantly shorter, but hopefully I can actually see something in, oh, come on. Oops, I copy-pasted too much. So this is, in fact, the actual structure of the tag that we were seeing. And this looks pretty promising. So basically what we specified for a tag, if we look back at the code, just to refresh your memory, it should look like this, you know, bracket, arguments, close bracket, with some white space thrown in there so we can, and I think basically you're seeing that here, open bracket, optional white space, tag name, which is a named group, optional first part of the argument there where like the first argument, the name of the tag can be an argument or it doesn't have to be an argument. Like if you just do B as a tag, oh, I can actually match these things now. That's a good point. Like that matches, or you could do B equals foo and that would match, right? So like it can be an argument or it cannot be an argument. That's kind of what this path represents. This is just the argument stuff we've seen before. It can skip over the remaining things. You could have white space at the end. That's still valid. Now this, unfortunately, like I wasn't able to embed 2 of this regular expression into it because we unfortunately have this problem where named groups conflict with each other, which is the thing I want to avoid. Basically, what I think I actually want to do is if I revert this to what it was so that I can kind of get example output, if I copy paste this regular expression into debugx, the problem is like tag name is duplicated, but what I would like to see is basically if the names were tag name 0, and apparently I wouldn't do that. I would probably do some character that that regular expressions aren't very unhappy with. What characters can I even do here? You can't do a lot of... What does Python actually allow for its named groups? That's good to know. Let's see. That's up near the top of the documentation. Group names must be valid Python identifiers. There's not a lot I can do. what I could just do is like that if I just want something fairly distinct as a way of sort of, you know, picking out the index of it. Basically, I want to do like tag name 0, tag name 1, single quoted value 0, single quoted value 1. I want every sort of duplicated group, and maybe every name just ends up being this way so that you can pull out a list. But I want to sort of process through the string when you render it out, replacing these names with names that don't conflict with each other. So now you can see, like, this would be, how did you know what my mouse was? It's a good ear. Yeah, ID for each name thing. Brackets are overridden to be the same as group on the match object, by the way. Oh, that's good to know. Oh yeah, I did read that, didn't I? Oh, well, should have been using that. It is a great mouse. I like it a lot. With those properly named, now you can see the full structure where we have that, you know, this whole blob here sort of representing an argument. You can see that that argument shows up multiple times. And if the system automatically replaces those names with the indexed versions, then I can make like a regular expression matchy thing that would actually look for all of the groups that have that name pattern, and it could pull them all into a list so that you could actually pull out all of those values once you've composed everything together. So this is where things get a little more interesting now with this, and where we actually get to the part of the system that makes it more useful. So basically, rather than just doing a plain old string thing, we might want something a little more advanced. Namely, I'm actually going to make a method that is sort of a render, in a sense. I want to be able to, so as I'm going to now be sort of recursively exploring through this sort of structure, this tree-ish thing of regular expression objects. If I see a named wrapper, I want to know what that name is, and I want to replace it. Actually, that's not so hard. But the thing is that I need to sequentially name all the groups as I go throughout. So that's kind of the challenge here. I need to have that context going through, basically. So the context, I think, doesn't have to be more than just like a map of names to counts. So it can like start at 0, and then whenever you run across a name, you can add yourself to the map and increment that. So that's what I think I'm going to do. I think I'm going to do like render. So this is going to effectively be like string, but it's going to take this names to counts map, or not map, dictionary. I'm in Python. This is going to do a really similar thing to this, but if the name is not none, then we're actually not just going to return self.name. We're going to get the count first. So we're going to do count equals 0. Or no, we're not. We're going to do if self.name is not in names to counts. Names to counts of my name is equal to 0. So we'll just initialize ourselves to 0 in that. And then we're going to actually do self.name. Boy, we got to do another format here. So we're going to do, I guess, now like ID or unique name is equal to the actual name, couple underscores, the ID, couple more underscores. And we'll format that together, self.name and names to counts of my name. Then our result will be set to this thing, so we're going to put that unique name into the named group. And finally, we're going to increment the named group so that it will actually be updated for future things. Hey, Pimenso, I am programming a regular expression wrapper, kind of, yeah, a general library thing. I have been working with regular expressions for the past few days now on some stuff for the Handmade network, and was running into some problems, really wishing I could compose regular expressions together and have names and things all continue to work out. So I'm exploring designs for that and trying to implement something along those lines. So that should uniquify the names. The convert to string thing now can actually just return render of self, but also then just an empty dictionary, just to initialize things. So what will happen when I run this? Invalid syntax. Apparently is not in is not how you do that, but not is in. Oh dear, not in. Why did I do is? Okay, now render is not defined, which is true because I didn't do self.render. And render takes 2 positional arguments, but 3 were given. What? Where? Line 36. Oh, right. Thanks. Got carried away. Man. You can tell I'm no Python expert by any means, but I do really like using it. What was that error it just told me? Unique is not defined. Well, that's because it's supposed to be unique name, not unique. Okay. Now the errors we're getting are no such group from down here where we're actually trying to just access the groups directly. But what we see here is that it's always 0 all the time. Dang it. Making some progress. At least we're inserting numbers into the names, but that didn't really work like I wanted it to. Now, I thought dictionaries in Python were passed by reference. Oh, this is stringing, so it's reinitializing every single time. Gotta actually call render and pass the thing through. Commander, please. Please, Commander. Okay, now render is not defined because, again, I can never remember to do self. Now render takes 2 positional arguments, but none. Not self. X.render. Goodness me. Okay, making progress. The problem is that some of the things in our list are strings, not wrapped things. So, so what I can just do, I suppose, I could find a way to do this with exceptions, or not. This is going to be kind of a gnarly list comprehension, but I want to see if this works at least. If it's an instance of wrapper, then we'll render it, else we'll just return the thing. And now, oh, come on, come on. I copy-pasted too much again. It's okay, we're okay. There it is. Tag name 0, tag name 1, single quoted value 0, single quoted value 1, 0, 1, 0, 1. It worked. Okay. That's some progress. We have, in a pretty nice looking way, made a regular expression for an argument and composed it twice into the regular expression for a tag, and it worked. That is pretty nice, and it produces, ultimately, a regular expression that Python can just use. You can remove the brackets around the list comprehension to make it a generator expression, so the string join can take a generator. Ooh, I didn't realize that's actually how list comprehensions worked. Oh. Oh, that's neat. I like that. That's really intriguing. That's so cool. That is something for me to learn about. Okay. Oh. Google was auto-completing for a second. Generalization of list comprehensions. I had no idea. Sure. Because it doesn't actually have to build a list, it can just use the expression to generate. Ooh. I like that a lot. That's really cool. Python continues to be very, very nice. Like, I mean, it wouldn't be my go-to for a lot of things because it is the more dynamic thing for a lot of software. I prefer to have, a type checker actually compile stuff. But when I'm doing more scripty stuff and just wanting to explore ideas, Python is so much fun. And I keep learning about these awesome features that make it really nice to use. Oh, it's the best glue language. I love it as a glue language. It's just so nice to script in. It's so readable. It lets you be so concise. It's so predictable though compared to other similar languages. Like I've used Ruby for stuff that's not fun. I use a lot of JavaScript for stuff at work, and that is not nearly as pleasant to just like write scripts in. It's okay for some things, but like Python is just so nice. EVE Online heavily uses Python for its backend. Wouldn't surprise me. I mean, like it's not like Python can't be used for serious stuff, and it certainly is expressive, if nothing else. So this is a little gnarly, but it does work. I'm doing that is instance in there, but it's okay. I'm gonna leave it for now. I wanna get on to other stuff. So if this thing see this. This is going to be interesting now. So one of the features that I would like this to have is named back references that also compose in this way. But how on earth do I keep track of indices for the named back references? Oh boy. Oh boy, okay. Let's start building it out and we'll get there. So, suppose I didn't want to do single quoted value and double quoted value separately, because they're basically the same. What if I wanted to do what I originally tried to do, which was the reason that I got mad at regular expressions in the first place? What if I did instead, we're going to name basically just, we're going to call it quote, and it's going to be a single quote or a double quote. And then we're going to have a function that's like backref to quote, right? So we'll do a back reference, a named back reference. So the function for that you'd imagine would be mostly easy, right? You would like, if you didn't have to worry about a bunch of name stomping problems, you could just do define backref with a name to return basically just this, where you would like make that back reference. And I guess you would throw that into a wrapper. But this isn't quite going to work. I mean, after all, if we run this, we will start to see a problem with it. Let's paste it in here and see what the problem is. Well, first of all, why has it done this now? What did the syntax come out looking like? Is that not what the syntax for a backref looks like? I thought that's what the syntax for a back reference looked like. Oh, P, right, thank you. I knew there was something I was missing. I wonder, do you know what the P stands for? I never really thought about it. Unknown group name quote. Yeah, well, yeah, you can't compile it, right? It can't compile it because things are invalid, but... Right, invalid group. This is the problem. It's not called quote anymore. It's called quote something. And keeping track of those indices is going to be kind of crazy because basically, you know, any amount of back referencing makes sense within like a certain wrapper, but you need to equally apply the index to all instances of that name within that regular expression wrapper, because this really should be quote 0, right? And this should be quote 1 if this was actually going to work out to a valid expression. And so this should work, right? Like it would refer to quote 0 and then back reference it again, which should let me do something like foo equals bar and have that work, or bar equals baz and have that work. Both of these are recognized. So that syntax is working, but we do have to actually keep track of the index. Maybe pattern. Yeah, seems as likely as anything else, I guess. Is there a formal grammar for regular expressions? I'm sure there is somewhere, but I wonder what they specify it in. That would be interesting. Python just like says regular expressions are special and ordinary characters. Ordinary characters are simple regular expressions, and then there are special characters, and here they are. They obviously don't define regular expressions in terms of regular expressions because that would get really, really gnarly. That's probably a sensible way to do it, but so let's think about how we actually do this within the context of this thing. So this obviously doesn't really work. We can't just return like a plain old wrapper and have that do its thing. We might actually need a separate sort of class or object type to keep track of, like, this is an object which refers to another name, you know? Are there other things besides back references that do that? At least that I care about. Like, we've got a back reference there. Are there... I mean, there's this crazy pattern, which I've never used, and I'm not too interested in implementing right now. The only things that refer to names are named groups and named back references. They have look ahead assertions, but those aren't named. They have positive look behind assertions, again, not named. I might just stick with backref for now and not try to do any more abstraction. Gotta catch up on chat. Hello. Don't know exactly what is going on. If I was joining regexes, I would parse each regex into an AST, join the ASTs, and recreate the string. Yeah. Certainly could. That would be one approach to it. I mean, that might even sort of be the right way to do it in some sense. But I'm also not interested in really making a regular expression compiler that compiles back to a regular expression so I can hand it to Python's regular expression compiler. I guess in a sense that's what I'm doing, and maybe that would just be a more elaborate way of doing that. This is more an experimental thing anyway. But I suppose, yeah, a parse tree would be another way of doing it. Effectively, like you could build a parse tree structure that's like just a little bit of a superset of regular expressions that keeps names kind of separate, and that when you actually render it back to a regular expression, it can do something with the names. Have I seen Python 3.6 F strings yet? I'm vaguely aware of other string formatting things, and I've sort of stuck with format because it works. Also, the Handmade network is unfortunately stuck on 3.5 at the moment. But let's look up what these things are. Python 3.6 F string. Ooh, inline stuff. About time. So you just put F in front of it, and then you can just throw values in the middle. Now that's nice. I was aware of the percent formatting thing, and sort of aware that that was the older one. Okay, that's good to know. The renaming process is similar to what is called alpha conversion from lambda calculus. Oh boy. I have not done much with lambda calculus. I've only scratched the surface of that like functional programming side of things. Had a great time trying to understand church numerals. Isn't that what they're called? Church numerals. Yeah. Really enjoyed that academic process of it, but I never really covered functional programming at all in college or anything, so I'm mostly unfamiliar with it. Lambda calculus, alpha conversion. Dare I go to Wikipedia? Alpha conversion allows bound variable names to be changed. Terms that differ only by alpha conversion are called alpha equivalent. I suppose it makes sense that you would need that in some situations. I really should take it upon myself one of these days to just like learn Haskell or some other functional language and just really try to make something with it, something interesting, just to really wrap my head around what's going on in that world. In any case, this is going to get a little more complicated. Because now what I want to do basically is I think at the time I start rendering, okay, well, let me read the chat first. The basic idea is to replace all the names and indices with canonical forms. What would a canonical form look like in my case? What I'm thinking should work in this instance is like if I saved a copy of the names to counts when I start rendering, and if anything at my level of regular expression is a back reference, that I can just use that index everywhere, and then I would increment the used index after the fact, and it shouldn't affect the back references. It's getting a little bit odd, but let's just try this idea, and I can maybe explore it, iterate on it down the line. That's just going to have a name. It really needs to have a name. And this is also going to have a render function on it, which is going to take an index. Instead of a name, replace it with the name plus the entire regular expression it came from, or something like that. I suppose you got a point there. I'm keeping track of numbers, but each wrapper could certainly generate an ID of its own and just use that, and then that index, that ID would be persistently present. That's a nice idea that I like. So one thing though is I do want the names in the end to be sort of easy to iterate through, because here's the thing is that I want all names to, if you use the same name multiple times, I want to have then sort of a similar group method on this regular expression thing. It would be nice to have convenient match methods that would actually let you then iterate over, here's all the matches for tag name, right? And if they were consistently named 0, 1, 2, whatever, then you could just loop through and build a list of all the matches. If I just did memory addresses or just IDs that are tied to a wrapper instance somehow, I imagine iterating would be more difficult. I could iterate over all the named groups, probably, and pull them out by prefix or something into a list. But I would want to ensure that the order is exactly as it is in the regular expression, which I get if I recurse through it in this way. I ensure that it always goes 0, 1, 2, 3 in the order that I encounter it. Does Python garbage collect in a way that moves stuff in memory? I don't know. But here's what I could do is just yeah, address is not stable if it does. I need it to be iterable in some way at the end, and that is the challenge here. So, I mean, like one idea that I'm trying to come to terms with is like I could just have an index here, right? And like, I could have just sort of a global, like, you know, you could almost just have like a global wrapper index that's 0, and then like when you actually construct wrapper, then it would be like self.index is equal to wrapper index, and then wrapper index plus equals 1, just to like increment it for the next guy, right? So like this would give every wrapper a unique number that would identify it, which you could then actually just use in here. So instead of passing around names to counts, you wouldn't actually need that. You could just do like you know, your unique name instead of names to count self.name would just be your index. And likewise, the back reference could render with that index as well, which would work great. And in fact, like this mostly would work great, I think. I'm kind of curious to try that. I screwed something up. It's because I added that down there. Local variable wrapper index reference before assignment. Uh-oh, wait, shoot, it's a global, oh no. Does Python have like static stuff? I actually haven't ever looked into this. Python static variable. Is this possible? Is this possible? Declared inside the class definition, but not inside a method, are class or static variables. Oh. I just corrected my understanding of Python classes and things. So then does it just copy that in? Yeah, okay. Fascinating. So then you wouldn't even need that. You would just have to, whenever you construct it, wrapper.index plus equals 1. Does this work? Does this work? Render takes 1 positional argument, but 2 were given. Where? Right here. That string method is redundant now, but names to counts is not defined because I don't need to do that anymore. Unknown group name quote. Well, it produced a thing. Let's take a look at that in debugX. Somehow I still managed to end up with duplicates, presumably because I didn't do self.index is equal to index. Does that even work? Clearly they were all like referencing the same variable. Or I guess I could, you know, just refer to the static thing. Fingers crossed. What? Hello, Commander? How is that? This is not how I want to select text, but okay. It's still not working. Did I copy too much again? No, I didn't. They're all ending up. Oh. That doesn't work either, and I'll tell you why. It's because we create our regular expression for argument once, and so this wrapper ends up with an ID, this wrapper ends up with an ID, and so on. They all have unique IDs, but then we just use it twice. And it has the same reference in both cases. It's not doing a copy. So that ends up just rendering out the same index twice and doesn't actually fix our problem. So on that note, the memory address thing definitely wouldn't work either. Like, just initializing it with an ID doesn't work unless I actually want to make a copy of this every time. Which I could, but like, I don't really want to. This doesn't feel like this feels like a concern of rendering to me, not a concern of initializing it with just the right ID. So let's toss that index, toss our index stuff. And rethink what we're doing there. In Python, can you pass around like a pointer to a number? Is that a thing you can do? I'm coming from Go and C and whatever else. Python pointers, pointer to number, to int, pointer to something. Passing by reference. Integers are immutable. Pass it around in a container that can be mutated, which is awkward. There's got to be a better way. Why do I have the variables in the class level in that one class? Well, I was under the impression that that was setting sort of reasonable defaults for something, which it sort of is. I didn't really understand that those were static because I never bothered to thoroughly learn Python's class system. I just sort of started using it. So on stream tonight, I learned that that was wrong. Value or empty array or empty list. What would that do for me? I'm not quite understanding. Like, would I put that somewhere that would actually solve my issue here? Oh, provides defaults in case of none. Right. Oh. Yeah. That would make sense, yeah. So I could just do, in this case, I did provide a default on that, and then I could do like, well, there's really no need for me to have those. I'm making my own weird Python conventions because I don't understand Python. So here's the thing. I would really prefer to have it be that every time I call render, we increment some global counter, you know, and like that way each node that we encounter along the way as we're rendering would increment that number, and we would then have an ID assigned to each one. But it does so as we're rendering. We're not like saving it on the thing to begin with, which means that recursing through would continue to work as expected. What I'd like to do is just like pass in a number here. If it were like another language where I could do pointers, I would like pass in just a pointer to a number. Each render thing could just like update that by reference and continue passing the pointer around so that each individual thing can increment it, but that will be reflected along the way, and it won't be that we lose that increment when we return back to the calling function. But that static example is pointless because name was none by default, and yeah. Right, that's what I sort of realized. So in this case, because I can't in Python pass a number by reference, apparently, I could maybe wrap it in something and yeah, use it as a pointer if you need to. Yeah, why not? I did this on my other Python project. We're gonna call it a render context that I'm gonna pass around. And this has an index on it which starts at 0. Yeah, right. Just use a thing that does pass by reference to encapsulate the thing you need. That's one of, like, that always sort of bugs me. Like, Python has this, Java has this. It's like, yeah, some things are passed by value and some things are passed by reference, but we won't let you have that control in your own code. It's like, if you're going to have passing by reference, if you're going to make me think about shared memory, then just put pointers in the language. Like, I can deal with it. But whatever. So then we'll just pass around, when we render it, we'll pass in a render context, and we'll have a context in here. I'm actually going to type context out because it's actually hard to type CTX. We're going to pass the context down. At the time that this thing passes in, then we're going to say index is equal to context.index. And at the end, well, I guess right here, context.index plus equals 1. We can just increment it there and then. Better get out your C++ compiler instead. That's a fair point about strings, I guess. But I mean, that's kind of the point. You know, if I was using Go, I could pass around a pointer to a string, and then I could just dereference it and update the value of it, and everything else would see that string. Like, I mean, it could be done. Other languages do it. You know, languages besides C and C++ have native string types that aren't just pointers to chars. But it's whatever. It's not that big a deal in this case. Like, it's a pretty small thing to have this render context, and like, someday, who knows, I'll probably have like another value that needs to be passed around while I'm rendering, and there we go. Now I needed a class anyway. So in this case, now we can just use index. We'll get to back references in a little bit, but yeah, I know, standard string, whatever. It's annoying that it's not part of the language still. But I know it's, yeah, just use standard string, it's whatever. So that should work, I think. Every time we render, the context index is going to increment, and we will end up with some different names. Let's see if this works. I probably made another little mistake, or not. It appears that that actually worked, and it's not doing the weird selection for me again. This quote is invalid, but I'm just going to delete that so we can see the remaining structure of it. In both places, or I suppose I could just do, like, I could just see what it was named. Like, this one's 8, and this one's 22. Okay. With that regular expression now valid, we can see that they do all, in fact, have unique IDs. So that's kind of nice. So now, I could get back references working. Before I do that, I do want to think about how I would pull out all of the matches of a particular name. Because now they at least follow a pattern, but like, if I was going to loop through and try to get all the tag names out of this, like, how would I do that? My render method could actually return a tuple with the regular expression and the maximum number of, like, the maximum ID that it ever came up with. And then I could loop up to that to pull out the list of items I need. That would work. Is that awkward? Is there a better way to do that? Because that would work. Because basically, basically say that I want a match function on this regular expression wrapper, right? Like, so this is going to be the standard like Python thing where it matches a pattern and a string. I'm not going to worry about flags for the time being, although flags would be good to add to this if I was actually making a proper library of it. This would first render itself, right? Like, we would get the regular expression string by stringifying ourselves. Oh, this needs to have self. So we can just convert ourself to a string. That'll do its whole thing, and that'll actually, now I'm going to say render oh, for goodness sakes. Okay, we're not just going to do string. We're going to do like actually, I'm going to call this render, and this is going to be like called render part. It's kind of just the partial thing of it. And so that's just going to do its thing, but then this is actually going to return a tuple of, well, first I'm going to have to actually save the render context into its own variable. So the context is going to be a new render context, and we're going to pass in the context, and we're going to also return the context. So that'll give us the value when we're done. So we can get the index out of that to figure out how high a number we ever actually achieved. So now we can actually just call render on ourselves, self.render. And instead of just returning a string, we're going to also get back the context. We can then get the match. Basically, now we can do like a proper re.match with the regular expression string against the string that we were given. And now we can start doing stuff with that result. Oh, that is redundant? Okay, good to know, thanks. Ah! What about here? Gonna bet it's redundant there as well. We'll see if my bet is right. Now with that match, we can actually pull stuff out. I'm gonna say that this always returns a list for a particular name because that's kind of what it's designed to do. And at least that's a reasonable starting point. Match starts from the string, search looks anywhere for a match. Oh wait, that's right. I forgot that was the difference. Match versus search, match versus search. 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 Right. This isn't alphabetized, it keeps throwing me off. Actually, what I probably want is like find iter or something. Oh, right, the character is at the beginning of the string match, the regular expression. Okay. But regex ache for like 30 minutes. So I could do find all. What I really want is find iter. I want to find all the match objects and pull stuff out. I suppose I need kind of my own match object if I'm really going to do this, aren't I? Find iter pattern string for match in find everything. Oh. I can just loop through, or no, I did want to do search. I'm getting my regular expression operations mixed up. I wanted to do search. I want to find. Yeah, let's just do search. This is search. It's going to find one instance of this, but then we have to loop through all of the groups in the match in order to produce my resulting sort of match object. I'm not searching for multiple matches like for this regular expression. One match, multiple named groups within that match. Is that clear to everyone here? There's a GitHub repo with no code that has 1,970 open issues. Well, that's amusing. Does it even have a README? Let's see what Python has in their match objects. This is important. Can I get all the groups? A tuple containing all the subgroups of the match, from 1 up to however many groups are in the pattern. Okay, group dict returns a dictionary containing all the named subgroups of the match keyed by the subgroup name. Now that sounds like what I'm looking for. Yes, indeed. Yes, indeed. For name and text in, oh my goodness, I am in Go. For name and text in m.groupdict. Wait. Oh, the default argument is used for groups that did not participate in the match. I don't care. Items, so that I can get both name and text out of it. Now this is where I actually probably need to build up my own sort of match object that would emulate a built-in Python match object, because that's kind of the idea, is that it would feel like the Python thing, but have these extra features. So I'm going to have my own match class, which is going to have presumably some kind of like dictionary, some storage in it for groups, where basically we're going to have like, we'll just say we have named groups for now. It's just going to be a dictionary that'll be from names to a list of matches, which is kind of the difference in our case. So the result is going to be a new match. This is going to be a little bit of an annoying case, I'm realizing, but I can actually do a little bit of a regular expression replacement here to get rid of the IDs at the end, which I can be assured that there are IDs at the end. So plain name is equal to, we're going to replace underscore underscore 1 or more digits underscore underscore end of string with nothing in name. Now I sincerely hope I got the order right. I can never remember. Sub pattern replacement string. Ooh, it said pattern replacement string and then I accidentally hit middle mouse. But pattern replacement string. We're going to initialize this in the dictionary if it's not already there. So if plain name not in result dot named groups, result.name groups plain name is equal to a list. I bet there's a more Pythonic way to do this, and you can correct me in a second. And then result.name groups of plain name dot append the text. We return a result now. This should will that give me what I'm looking for? I'm not gonna bother with operator overloading yet, but I am going to define group on it so that I can sort of use this down below in a way analogous to how I was doing it before. So we'll take a group, and this will just return self.name groups of name, just so that I can access it down here. So rather than do all of this stuff, I'm going to now do match is equal to regular expression tag dot search. Obviously I shouldn't have pattern in there. It is the pattern. Okay. Just the string, thanks. Search the string, just tag. We're going to search my example tag string, and then we're going to print m.group tag name. We're going to print m.group quoted val. Oh, I should just change this to quoted value now because we're doing the back references. Oh, and the back references aren't going to work yet, so I got to be close. Do I think John will use this? Probably not. It's in Python. We're going to print the group var value, and that'll be all. So this is totally not going to work yet because I just realized that I didn't really implement back references. So that's kind of the next step in this saga. Where are my uses of render that I've apparently gone so badly wrong? Render part. Unknown group name quote. I am actually going to re-implement the string method on this, just because, oops, it was really, it's annoying to just see like main wrapper object here in my output. Return non-string, well, turns out I didn't even need the render context to be returned anyway. Whoops. Whoops-a-daisy. That can get cleaned up later. Too many values to unpack. Yeah, indeed, too many to unpack. John, I think, meaning Jonathan Blow. I remember him tweeting a long time ago, like asking if people had made a more approachable solution to write, like a more approachable version of regular expressions because they're kind of gnarly. I actually remember at the time being inspired and starting something along these lines, but it didn't really go anywhere. And then me getting annoyed with regular expressions over the past few days was like, oh yeah, this would be kind of a fun little experimental stream project to do. Obviously it's in Python. If I wanted to provide something like this in John's new language, then maybe he'd use it, but nobody can use that yet. I'm waiting patiently for it to come out in some sort of beta release, but it sounds like it'll be a long time. Eagerly awaiting it, though. If you're not familiar, Jonathan Blow is the creator of the games Braid and The Witness. He's a really good programmer, and he's working on his own language, which is going to be a C++ replacement with a lot of features, some really interesting features, like full arbitrary code execution at compile time to influence how your code compiles, like a crazy level of arbitrary metaprogramming built into the language, which means you can even have like all your automated testing, all your build tools, all your other stuff, all written in the same language as the rest of your code, all working cross-platform because it's all just in the language, and it looks super, super nice in that regard, and in a lot of other regards, but like, anyway, patiently waiting for that to come out. Won't be a while, but C++ is getting closer to that now. Well, John's gonna beat him to it. It's actually crazy. Like, it goes so far beyond const expr and whatever. Like, I don't know. I guess I don't know what constant expressions in C++ can do these days, but like, he has a demo of him like running a game. You know, just he has a game and he can compile the game and run the game, and then he can just flip a compiler flag and it'll compile all that like to bytecode and run it in the compiler. So now the compiler is a bytecode interpreter, and it also runs the game perfectly with visuals and sound and everything. And it's like all like that amount of arbitrary code happening at compile time, and it's wild. That's probably the feature I'm most excited about, because I spend a lot of time at work wrangling different tools. And it'd be so nice if all the tools were part of sort of the same unified process. Let me find it. Let me paste it into the stream. He's got a few. Jonathan Blow, new language, programming language for games, the playlist. He has a demo of compile time execution here. This is early on,
you either have to make
so it's
an assumption that breaks
not even as is the audio okay? I think I checked the audio before, and
like,
it should be a fairly reasonable, quiet-ish volume below my speaking level.
values are
Um,
non-constant and your functions are constant, and then
if
we'll
I can
give you
actually find it,
to like change. And I've got it set to. Can you guys let me? That's right.
come on, John. Yeah. So
So here we go. This is running in bytecode on Linux at compile time.
all the particles, all the graphics, all that.
Woo! Woo! I'm just killing him. And then it compiles, and now I will run the actual program. So now it's at runtime in a slightly better frame rate. The frame rate is probably a lot better than it looks on OBS. Like, I think the webcam is.
I mean, it is a compiled language. What the compiler can actually do, though, is compile it to a bytecode that it can then interpret. I mean, you know, sort of imagine it compiling to its own little assembly language that it can then run through. Yeah, right, you can play a game while your project gets compiled. I think his next one, like, it was this one, the runtime and compile time type information one, is also pretty slick, where he has
by running
this,
the demo program.
is it just early on in the demo?
Body
You never,
on the
like,
left, part of the body of it's
or this is Go Bananas classic
we'll talk
demo.
about what we're seeing. Yeah, I did read.
I'm not seeing it.
Go off topic. I'll answer that after the stream.
Aha. This has Go Bananas.
Sticking through, for example, being compile time code. You really want to be very clear. Do this. So I've got this variable Go Bananas here, and if it's false, then I just do this very vanilla compiling. But I'm going to change Go Bananas to, actually, let's not do it that way. I could change it to true in the source file, but I could also do it here. I could say, you know, the same thing as I did before. Let's say run Go Bananas equals true, because that's actually a mutable variable, right? It's colon equals. So I can set it. And I didn't spell it right. So let's do this, and that's not spelled right. So this is better than something like it. All this is, everything's good.
Okay,
so now
Go
we're going to
Bananas.
Go Bananas and see what happens. Now, all this is compile time code right here. And we're playing music, and we're compiling procedures one at a time. And the procedures are sort of streaming in, and we're getting some kind of histogram about what's in our program, which seems interesting. So I can actually toggle histogram between different modes here. This is the starting of some kind of simple IDE for watching what's going on in your program. I left the compile all on here now, so we're actually compiling both the debug and release builds right
So
now.
yeah, this is the
So now this histogram
level of
let me
craziness. Like
please,
all of this compile time stuff is available to you to do literally whatever you want with, and it can modify the resulting program. So like yeah, it's compiled, yet it can compile its code at execution time and run it and modify itself using that code. Like you can like just put in a run directive and it will run that code at compile time, and functions that are run at compile time have access to like a compiler context from which they can grab information. Like you can get like compiler messages about procedures being compiled, and you can get all sorts of information about that compilation process, direct access to the contents of procedures. So you can modify them, so you can do all your metaprogramming level stuff, and it's like, yeah, which is all really cool. You know, certainly gets rid of the need for a lot of the header parsing tools and whatever other craziness you have in like C++. Like if you've ever done stuff in Unreal, they've got their own header tool that does a ton of work because they have their crazy macros, and like C doesn't have enough, C++ doesn't apparently have enough reflection to let them just do that in the language. And furthermore, though, that's all happening at runtime, right? If you were to do it all using reflection, whereas this is an enormous amount of introspection, but it happens at compile time and produces a binary no more bloated and no more slow than just the native thing if you had done all that work by hand. So it's so cool. I should learn Haskell. I should, for a variety of reasons. So I can have Jai at runtime replace a function while the program is running to do something else. I don't think it can self-modify at runtime because it does provide a binary executable in, you know, assembly or not in assembly, but in whatever platform-specific machine code. But at least during the compile process, it can self-modify. So I'm sure, I think it has a fair amount of runtime reflection too, if I'm remembering correctly. But you probably don't actually need a ton of that if you can do all that introspection at compile time instead of runtime. So it's neat. I can't wait for it. What was I doing? I was going to make back references work, because back references don't work. So back references need to render somehow. I really need to break this. Yep, back to regex. Jai is very exciting. We call it Jai. The file extension is Jai. He hasn't officially named it. He also says he's going to do another pass on the syntax, but he's already written. Oh, hold on. Time out. He, like, besides all the cool features we have here, it also compiles so fast I can't even believe it. Let's go into one of these game engine programming stream recordings that he's done and just watch him compile the game
we do
at
this
some point.
actions, right? Is the thing modify creation level.
So that, if we, oh shoot, I gotta back it up and just pause it right there at the end of the compile process. Okay. So in that incredibly short amount of time, it compiled over 84,000 lines of code, of which half a second, so it took a total of 1.2 seconds to compile all of that from scratch with no like caching or partial builds or anything like that. And 0.45 seconds of that 1.2 seconds was Microsoft's linker, which he has said he's going to eventually replace with some other linking utility of his own creation that will do it faster. And he says he thinks he can get a lot more performance out of it. And like, this is already like, to compile 84,000 lines of code in just over a second is already so much faster than anything else I've ever used. Like, I use Go all the time at work, and Go is known for being fast to compile. And like, we've compiled less than that at work, like when we were accidentally compiling all our dependencies all the time, instead of caching those builds. Like, it was taking several seconds, like on the order of 6 or 7 seconds, I think, sometimes, to compile a project that wasn't huge. It had a lot of dependencies in it, but even so, it didn't seem like it should be all that much source to compile. I don't think it was on the order of 84,000 lines, and it was taking longer than this. So it's like, you're already way faster, and you're going to improve it. He's good at what he does. Okay. Really back to regular expressions. So this is getting annoying now. Like, this thing is too long a generator function or list comprehension now. It's cool to have it in a generator function, but I am actually just going to make like a list of rendered things and just loop through. So for thing in self.wrapped, if it is an instance of backref, then we're going to render that appropriately. Just result, yeah, we're just going to like render.append thing.render with an index, namely the index that we were given. We'll add a render method to backref to make that happen. That's just going to return what is this going to look like? We're going to use a fun format string for this. It looks like p equals self.name 2 underscores self dot, no, just index 2 underscores, and that is all. It's not coloring that very well. Losing my train of thought here. So we'll render the backref with an index. Else if it's an instance of wrapper, then we're going to append just rendering that wrapper. Sublime did a crazy thing there and inserted something for me that I didn't want. Else we're just going to append the thing itself because it's like a string or whatever. With that in mind, we can now just say that the result is joining together rendered things. And then we can do the resulting like name group stuff. Oh, this can be consolidated into one thing probably. If self.name, I don't need to do is not none. I can just do if self.name. Do that, else return that. So we'll do a named group or an anonymous group, and we don't need that redundant anonymous group around a named group. So that'll make things a little more concise in some cases. Not a huge improvement, but it's something. So let's see if that works. It did produce a regular expression, and let's see if it's valid this time. It isn't, I don't think. The back reference I'm noting doesn't actually have the numbers in it, which surprises me, honestly. Why doesn't it have the numbers? What did I forget to do? What did I forget to do? Oh, right. I didn't return a backref. I just returned a wrapper because I was fudging around the issue earlier. But now, we're going to just make a backref with the name, and hopefully this will actually do what we want. Well, it's progress. It produced something. Apparently, it still doesn't understand the groups. The main problem is that you aren't using a piston arm. Oh, man. Oh, man. Oh, okay. So this didn't quite line up, which is interesting. Is this what they call an off by one error? I referred back to ID 7, but the quote ended up with ID 8. Not sure why that would be. I pull out the index. This should be set to, by value, this is a different thing now, and incrementing that index shouldn't make a difference. Oh, but you know what? Every named thing is like a separate wrapper, and therefore it increments again when we go to render that. So every named thing is going to have an ID of 1 greater. So maybe I need separate objects besides just wrapper for backref and for named. Seems fine to me. Let's make that happen. Wrapper class named group. Takes a name and probably a wrapper. I probably want it itself to have a wrapper thing when all is said and done. Self.name equals name. Self.wrapper equals wrapper. It's going to have its own render thing. Which also takes an index. But this returns the named group syntax instead of the backref syntax. Hi, Tactile Dactyl. Yes, a domain-specific language that compiles to regex. With the intent of being able to easily compose regexes together without losing features like named groups and named back references and that kind of thing, which normally cause problems if you try to just like add regular expression strings together. So that's what I'm wrangling right now, is just trying to ensure that all our named things, like, in our output, we want things to have, like, if we named it tag name, then it's going to be like tag name 2, tag name 15, whatever. Like they're all unique, and then we can actually pull out a list of all of the named matches for a particular group. So right now, we had a bug in it basically where you can see this was the group that was supposed to match quote 8, but then the back reference ended up with quote 7 because I've got mismatched numbers because of how I'm incrementing things, and it's not working exactly as I had hoped, but that's fine. So I'm going to make a named group thing which can kind of render separately. I'm just going to copy paste this for now. I could come up with a better polymorphic thing later because these are sort of identical, but for now it's fine. We will just render the name group or the backref, and it's fine. Oh, this is incomplete for the name group because rendering this actually mandates that we pass in a context as well and render the regular expression thing that comes within it, namely this right here. So that would be self.wrapper.render part, I suppose, which takes a context. The name render part is going to change, but for now it's fine. So these are different. This takes an index and a context. Don't do that. Sublime is doing weird stuff. Am I parsing XML with regular expressions? No, I'm not actually, although it's a similar looking thing. I'll show you the example. Yeah, fiddling with regular expressions without parsing them. Yes, I'm trying to sort of, it's a two-part goal here. First, make a way of creating regular expressions that is a little more self-documenting and doesn't result in a really complicated string that nobody can read without using another tool or spending a lot of time. And the other thing is to handle names in this more graceful way to avoid problems that I've been having over the past few days where I really want to build up more complicated regular expressions out of smaller ones. And I want to be able to get to use names in those regular expressions without it failing to compile because the same name group shows up in two places. So that's kind of the objective of what this thing is. It's not a super serious project. It's more of just an exploratory thing. Just to sort of see what's possible, if it works, if it's nice to use, you know. So at this point, I forgot if I needed to do any more work, so we're just going to run it and see what happens. And it takes 2 positional arguments, but 3 were given. That's on line 125. What did I do? Right. Name doesn't return a wrapper anymore. It returns a named group, which takes a name and a regex-like object, except that I'm actually going to wrap the regex-like object in my wrapper class that I've been using. Wrapper object has no attribute name. That's also true. That's on line 68. Indeed, we no longer need that aspect of it. We can simply return that group as it is. Did this work? Is that what I'm seeing? Let me remember what these at the bottom are. So first of all, here's the regular expression. Let's drop that into debugX so we can look at it. Oh, I should clarify now for tactile dactyl what I am actually trying to match. So what I'm actually trying to match is the BB code format for the Handmade network. I'm on the technical staff for the Handmade network. We've been working on a BB code parsing thing, and the BB code itself basically looks like, you know, if I just reply to a forum thread and start typing, you know, tags look something like this, where you've got, you know, it looks something like an HTML tag, but with brackets instead of with angle brackets. It's got sort of a similar attribute syntax, although the first, like the name of the tag can also sort of be an argument. So for example, I could quote someone else by saying, quote, equals Delix, and then like, Delix said this. If I update the preview, you'll see that this actually compiles to like a block quote. You know, there's a bunch of these different tags, but basically, since we've been working on a parser for this, I've been making some regular expressions as part of this to try and actually parse out the different parts of it. And so the situation I ran into is I had a regular expression for an argument, so that I could take a tag that I recognized and pull specific arguments out of it, attributes, whatever, you know, I call them arguments, but they're analogous to an HTML attribute. The regular expression for that looks something, it would match stuff like this, where you can have like a name, an equal sign with white space on either side maybe, and then either a single quoted, double quoted, or bare value, or you could have no value at all. And so like that's kind of the syntax of just an argument. That on its own makes a sort of complicated regular expression. A tag looks something like this, where you've got effectively an opening bracket, white space maybe, and then at least one argument, and then maybe more arguments separated by white space, and then maybe more white space, and then a closing bracket. And the thing is that in order to properly recognize this, you really have to like fully recognize arguments, right? So you kind of want your, if you were doing this in like a proper like grammar parsing tool, you would actually be doing some kind of tokenization and building up the, in a recursive fashion doing this. To do this with regular expressions, you kind of need to hard code the recursion yourself by embedding regular expressions within regular expressions. Doing so with named groups has all kinds of problems. You see like that the regular expression for an argument would show up multiple times in this, and then any names within that would clash. Python would refuse to compile it, and you have a bad time. And so that led to me trying to strip names out of it for when I want to include them in each other, but then back references don't work anymore. Ugh, this is annoying. I wish regular expressions, like I wish I had some nicer ways of using regular expressions that would actually give me the ability to compose regular expressions inside each other like that, build them up in a more intuitive, natural way. A little bit of a rabbit hole, yeah, whatever. Oh, Lumi, I hope you caught part of that explanation. Thanks for stopping by. Yeah, so that's the basically a DSL for regexes that provides a little bit. It's a wrapper. Part of it's sort of a DSL for making them, because I like a syntax like this that sort of self-documents what your regular expression is doing, but also a little bit of a wrapper around them so that as part of this you can just drop in another like full regular expression complete with all the features you would hope it has, and it'll just work, right? You can have multiple named groups in different places that'll work out in that. Yeah, it's kind of funny, isn't it? I'm not saying that this is like, if you find yourself in a situation where you do have to do a lot of this recursive stuff, it's probably true that you should be doing a more robust parser anyway, but like with just one thing to recognize in this BB code language, namely a tag, it's like, oh, I do not want to make like a full tokenizing thing, especially when you have so much arbitrary text content to deal with as well. Like, it would be such a pain. Having a regular expression that can just find tags makes the whole process way easier. You can't parse XML with regex? Well, now you can. So there. Yeah, I know. Don't get too excited. You say I've solved it, and well, maybe, kind of, maybe not. Yeah, BB code is pretty similar. It's a limited subset that uses square brackets instead of angle brackets. But effectively, we are doing an XML thing. I never really thought about that. Aren't there JS parser generators? Yeah, I mean, there's parser generators for everything. I didn't want to use one. And like, we're not using this system. Like, we have a working parser that doesn't use this. I just had to not use named back references because there wasn't a way to use that if you're composing regular expressions together. So back to what I was doing. Mainly, we can see now, now that you kind of know what this structure looks like, we've got the full, we've got the regular expression for an argument here. We have the tag name, and then maybe we have the equal sign and then either a quoted value or a bare value, and that's using a named group and a back reference to that named group. Then our tag has the beginning of the tag, an argument, and then 0 or more pairs of white space and another argument to, separate out all the arguments in the line, followed by the closing of it. And so you see that that regular expression with named back references appears in 2 different places in this regular expression. And the system appears to be actually producing something useful with that. If we look at it in debugX, we can see that the numbers don't go up sequentially, but that's okay. We've got tag name 1 here. Basically, we just had to ensure that all these named groups have a unique ID appended to them. So this is tag name 1 now. This over here is group quote 7, and then a back reference to quote 7. This is quoted value 7. They all have the same ID because they occur at the same level. So if you have, that's okay, I think, to have all the named things at a particular level of regular expression, in a particular wrapper. That's okay if they all have the same ID, because it wouldn't work for you to have multiple of the same named group in a single regular expression anyway. So this sort of composes in the same way with that same restriction on a single unit. This is bare value 10. Over here we have that same quote and back reference pair again, where we have quote 20 and back ref to quote 20. And furthermore, it's actually working on my test cases, where you can see this is the full regular expression for a tag, and you can see that it's matching just b equals foo equals quoted bar equals single quoted baz. It's working, it's doing that. So that is actually exciting. And furthermore, now the question is whether it's actually, yes, it's matching. Is it allowing us to extract the data we want? Because the thing I wanted it to do basically is you should be able to ask it for a tag name and get back a list of all the matches for tag name. So that's what I'm trying to do now. So the first group that it prints is tag name. The second is the quoted value. The third is the bare value. And what we're testing this on is this tag up here, which is quote equals delix, post is 1, 2, 3, foo equals bar, and baz. For tag name, we would expect to see just quote, because it's the first. Okay, so that's not quite right. Really, it shouldn't be tag name. It should just be name, like arg name or whatever. Okay, that aside, we should be seeing for the name group, I would hope to see. I'm not going to see that, am I? This needs to be worked on. The desired output would be quote, post, foo, baz. I'm going to write that down. Quote, post, foo, baz. Because those are the 4 instances of the name that were matched throughout the string. I did a search actually, so maybe that's not what I expect anyway. I got to think through what some of these things are. At the very least, I should see those values in there. For quoted value, I should hopefully see delix and bar maybe. And for bare value, I should see 1, 2, 3. So let's see what the program actually produced for me. Well, we see quote and baz, so it found those 2. Delix and bar for the quoted values, that worked, and none. None and 1, 2, 3. Okay, so this is not quite working. But it is matching, so we're close. Now we have to provide kind of that interface to that, kind of provide the interface to everything. So this group here is my own match object. I'm sort of making my own match object that looks like the built-in Python regular expression match object, so that it's sort of, they operate in sort of the same way. But I got to think about what it actually should return. If I do a search, because what a search means is it finds that particular regular expression anywhere in the string and returns to me information about what went on inside. I would expect in this case, since it matches the entire tag, that it should come back with quote post foo baz, that the quoted values should come back with, I suppose I want it to be none, or no, quoted values I would want it to be delix, none, bar, and none. Right? Like if, oh, this gets kind of intriguing, doesn't it? There were 4 matches of the sub-expression arg within this tag. And since these groups belonged to that sub-regular expression, you would sort of expect all 4 to come up. Whereas, say that tag regular expression itself had a named group in it, you would expect that to only have 1 element in it because the overall tag only matched once. Boy, that sure is intriguing. It would probably not be that hard to just return like as many instances of that group match as there were, like throw away nuns and just return that. But that makes it so hard to correlate things, right? Like you would, but on the other hand, that's just the only thing that matched. I'll have to play with this. You're trying to parse a tree, not a list of results. Maybe. This is now very uncharted territory for me. Like this isn't like, you know, the kind of stream where I have that I already like did a complete solution beforehand. Like this is an exploratory problem. I'm going to just play with it and see what values I do get. Like throwing aside what is sort of desired, I want to see what I can get out of this. I'm going to print each name as it comes along because I'm curious to see what the regular expression thing is actually matching. So we're matching name 1. Yeah, so there's only going to be 8 things. Oh, you know what it is, I think. This is interesting. Because I did a Python regular expression search, each particular named group only comes back with 1 thing. Or is that just always how it works? Because it does return a match object to me, but normally you don't have this concept of like aggregating across multiple matches of the same regular expression. Like your regular expression would match something, and some groups would have a match and some groups wouldn't have a match. Done and done. You couldn't possibly have like, I thought there was something in this library though that could do a little more than that. What are the different methods that we have? We've got search. It finds the first location where it produces a match. Match just starts at the beginning. Full match. Make sure the whole string matches. Find all. Returns all matches of it. If 1 or more groups are present in the pattern, return a list of groups. This will be a list of tuples if the pattern has more than 1 group. find iter just returns match objects, and each match object would each have, you know, its own group. Every single group can either match or not. I don't think you ever have a situation where a match, like a group from a match, I don't think it could ever be a list. But it could, right? Like, if the same group repeated, then you could have a list of matches for that group. Couldn't you? If a group matches multiple times, only the last match is accessible. That explains why it's coming back with quote and baz. Quote is the first instance of regular expression of RE-arg, and baz is the second instance of RE-arg matching the last time that it actually happened. Grammar classes. Let's look. I don't. So my Twitch chat is open on another computer actually, so I can't actually open up the same Stack Overflow answer easily on the same computer. But to read what it's about, you can't parse XHTML with regular expressions because it's like a different grammar class. HTML is a Chomsky type 2 grammar. It is context free. Regular expression is a type 3 grammar, that is to say a regular grammar. Right. I mean, there's different levels. The Chomsky hierarchy is kind of an interesting thing. I'm not going to get into how grammars work tonight. That was one of my favorite things from my discrete math class in college, though. Are you aware of the parsec library for Python? I know that there are parser generators. Like, that isn't really, for this BB code application, I did not really want to get super deep into what it takes to do like a full parser where like how would you tokenize someone's random forum post? It gets, I mean, I guess you could just do each character, and like, you know, a quote or an opening bracket would throw you into possibly a tag, and maybe your grammar could pick it out, you know, like it would work. What I wanted to do to simplify the actual like parsing process was to tokenize this thing, not really character by character, but sort of tag by tag, to have like, this is effectively a token. This, you know, this is a token. This is a token. This text up until you hit another tag is a token. And from that, then you've got a much more limited list of like, this token corresponds to an opening tag or text or a closing tag, and that's like basically all you have in terms of like the tokenizing process of your parser. Technically, I guess you might call that your lexer, but it's all rolled into one in this thing. From there, it's fairly easy to just go like, okay, I've got tags, I've got open tags, text, and close tags. From this, I can build like a really simple parse tree and then start processing that to actually look at the arguments of specific tags. Can, you know, change the types of nodes to something more specific, handle tags which shouldn't have other tags within them, and so on. And like, it's been working, and it does work without my fancy regex thing here. It was just like, this was an experimental project inspired by those difficulties with composing regular expressions together, just sort of going like, could you do this? The answer apparently is yes, you can, and like, I appear to have actually solved the fundamental problem of composing regular expressions. Now the question is making a nice interface for that so you can get data out of it that you want. Then you have a token stream as output of the lexer, which goes into parser. Regular expressions is useful, and tools for regular expressions are useful. I mean, yeah, that's sort of my thinking on it, right? Is like, what is a token is kind of the first question, I guess. So if you're going to make like a proper parser, in most programming languages, obviously a token is like a character or maybe an identifier if you go that far, right? Like you can split things into, in a programming language, you can maybe just split things into keywords and symbols, and then that's your token stream that you can then use to start building up your actual syntax tree according to your grammar rules and that kind of thing. And like, I'm familiar with that approach. Like, I did a compiler class in college. I've done some other stuff along those lines. Like, I'm familiar with that. For this, it's not really a programming language. From my perspective, it's a fairly simple markup language for which I don't really want to go like the full grammar route and exhaustively specify in such detail how all that works and deal with the overhead of a parser generator and however you have to integrate that for a thing which effectively has one construct, a tag, which we then just sort of implement in some different ways. But like, those don't even really have to be specified in the grammar. It's like all the parser, like the tricky parsing aspect of it, all it has to do is like recognize a tag, understand nested tags so that you can have sort of that, you know, recursive element to it, and then have some fairly straightforward code to just like say, oh, this is a quote, so look at these arguments and render it this way, you know. Bracket equals token, parser combinated from earlier, you don't need a lexer really, you just combine a bunch of functions and it's your parser. Yeah, sure. I admit that part of it is motivated by the fact that you may notice this says handmade. This is all for, I mean, or at least inspired by work that I was doing for the Handmade network, which is a really cool thing. You should check it out. But it is a community of programmers and programming projects with a focus on simplicity, sort of avoiding the use of, there's a certain element of like avoiding libraries to it. And it's not like you should never use libraries, but like sort of doing it yourself is a valuable exercise. Often you can come up with a solution that's much more applicable to your specific problem than a library that someone else made for the general case. What I hit, performance libraries, and like generally the intent of it is sort of to understand everything your code is doing. Like, even if you do use a library, if you're trying to really make it in sort of this handmade way, you should be like, try to be really aware of all the work that library is doing, understand exactly what is going into your program. Like, it's almost easier to define as like a handmade project is like the opposite of a glue code project. Like, what is definitely not is taking other people's libraries and gluing them together into something. And because like, while that is a fast way to build software, there's a certain element of craftsmanship to it. Anyway, example for parsing JSON. Yeah, I'm not saying that parsec is glue code. If anything, what I would write would be glue code between parsec and my other thing. And I just think this is a simple enough application that I don't need to do a whole parser generator. And this is a fun exercise anyway. Yeah, for sure, the not invented here thing. Handmade definitely has a lot of that going on. But it's like, you know, like it's one thing for your work because it's likely a waste of time for your company to be developing this whole thing that you'll then have to maintain and whatever. On the other hand, if you don't do a lot of these things yourself or learn how to do a lot of these things yourself, if you're not aware of sort of the problem-solving strategies that they use and the approaches that there are, you're likely to be a lot more limited in the sorts of problems that you solve in other places. Like, you know, if you learn how compilers work, then hopefully you see a problem at your job where you're like, oh, I know an elegant way we could solve this, and at least maybe you know what to look for, and you understand if you have a problem with it, kind of what's probably going on behind the scenes. You can reason about it better, so on. It's a good exercise. It's not always like the right thing to do always all the time, but right. I've done plenty of library glue, and it's rarely a pleasant experience. They better be darn good libraries. They're usually not. Anyway, as I said, this is like an experimental thing anyway. I don't even think I'm going to use this because we have a working system that all I had to do to fix our these back reference issues with our BB code parser were don't use back references. You only use them once, just like do a single quoted case and a double quoted case, you're done. It works. Like this is really just an exploratory sort of fun project. And it's intriguing to see that this is actually letting me compose regular expressions and sort of like step up or down a grammar level depending on which way the Chomsky hierarchy goes. Down, I guess. Is our lower numbers higher in this hierarchy? Anyway, supposing I do a regular expression search, this gets a little tricky. Like the interface I would expect for this is that by the name search, I would expect it to do basically the same thing that the built-in Python regular expression search does, namely find the first match of that regular expression in the string, and then return me a match object with information about it, like a single match object. In my case, because of this fact of groups having more groups having the possibility of more matches, this gets a little more complicated. I'm not sure that the returning a list of things is really the right thing to do. Because like what I was noticing before is like say that we had say that this was more like an HTML or XML tag where you actually have some name up front and then arguments or attributes, whatever you want to call them. Well, if you did that, then you might want to identify it by another named group here. So this would be like name, tag name, and then that would just be, a regular expression, A through Z underscore dash, whatever sort of characters you allow for your tag name. And then I guess you'd probably have a little bit of white space and then your arguments and things. So here's the thing, is that if we did this, now we've got a named group in the tag, and we've got named groups in this sub-regular expression. And the problem is, what on earth would you expect these things to return? Like, if that's I'll name this arg name, and this is tag name. So clearly there's only one tag in this string, right? It's the name tag with arguments quote, post, foo, and baz. So you would really expect the tag name to only come back with name. I really shouldn't call it name. I'm going to call this my tag. Then for arg names, I was saying that, oh, it would be neat if it could just return all the matches of it, because then it would return to you quote, post, foo, and baz. But like, whoa, this group returns one element, and this group returns 4 elements. And quoted value here, only 2 of these are quoted. So would you expect it to return 2? Or since there were 4 argument matches, spread across 2 regular expressions, would you expect it to return 4 things? Or 2 things, 1 for each regular expression? Because right now it could just be like, you know, both things could come from this one regular expression. It's like, this is kind of crazy. It doesn't seem like a nice design actually to have it return all those things. So I think actually, in keeping with the Python standard library way of doing things where it returns the last match, and in keeping with the fact that you are building these out of smaller regular expressions anyway that you can easily do more searches with, I kind of think you should just return the last thing. It should just return my tag. It should just return Baz. It should just return, I guess, bar, and the bear value should just return 1, 2, 3. And that's pretty easy to do. The easiest way to wrap compose probably is just to take the result from the outer match and pass it into another regular expression to pass the inner expression. I mean, yeah, sure. The problem is, in order to match the outer thing with a regular expression, you have to have the entire inner thing as part of that regular expression. So, I mean, you could do that, but you'd have to have like the full regular expression and then pass that result down to a smaller regular expression that it was built up from, and so on. Like, doing this with regular expressions requires you to build very large complex regular expressions for properly recognizing these large complex things. Like, regular expressions don't do recursion, so you have to like do the recursion yourself. It has its limits. Yeah, sure. Well, I'm not so sure. Like, if I had something like this, what would my tag regular expression look like? I can't match the whole tag to pass something else down to the argument matcher if I don't already know what an argument looks like beforehand, so that I can see name, argument, 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 argument. I'm going to go back up to the search thing instead of doing this initializing of instead of like doing a list, I'm just going to say it equals that, and now it's going to return a single string instead of a list of things. And when I run this, nothing works because there's no group dictionary thing. Wait, why? Oh, it's none. It doesn't match the string anymore, so it just comes back with none. Right, so if not m, return none. Gotta throw that out in front. And furthermore, I need to remove my tag from the, I need to undo those changes that I made to the expressions there so that I can continue to test things as expected. Key error, tag name. Well, that's true, because tag name isn't a thing anymore. We just have arg name. Okay. For the quoted value, or for the arg name, we got Baz because it was the last instance. For the quoted value, we got bar because that was the last quoted value, and for the bear value, we got 1, 2, 3 because that was the last bear value. That worked. I can remove some of those prints that are really bogging me down, really making my life confusing. That actually seems fairly reasonable because the thing is, like, the use case that I have in this parser is like I recognize a whole tag, and then having recognized an entire tag and sort of pulled that out as its own string, I can now search just that tag for arguments using the regular expression for an argument. And at that point, it's easy to just do like a find iter or a find all or something like that to actually return to you several of these match objects that you can pull specific groups out of, rather than trying to aggregate all of the matches together into one long thing. Which is really the more sensible thing anyway, because some things are going to have quoted values, some things are going to have bare values, some things have no values at all. It's like, what do you really, how do you aggregate all that crazy group information together into one thing when you don't even go down some paths on a particular regex? So I actually like that interface for search. It is sort of in line with what this is doing. Only the last match is accessible. Yes, good, great, good, yes. Let me implement match in like the same way. Actually, I'm gonna do a find. I'm gonna do a find iter. Try to recreate the find iter method so that I can parse out each individual argument. So find iter returns an iterator yielding match objects over all non-overlapping matches for the regular expression pattern in string. Cool. So this should be pretty easy, I think. Let's leave search up there. We'll define find iter. What's the signature look like for that? Pattern, string. We only need the string because we are the pattern. We're in the regular expression wrapper right now. We're going to render the string into a regular expression, and then we are going to find iter that across the entire string. So we're going to do like matches is equal to yeah, sorry, was just thinking if I needed to actually do this custom match object or not. I do, because of the unique IDs that I've put on everything. Matches is equal to find iter of, what do I do up there? The regular expression string, the pattern, and the string that I'm actually matching against. Does that return none or just an empty iterator? I would really hope it returns an empty iterator, and it does. So for match in matches, I'm going to build up my own result, which is going to be a list. I'm not going to bother with a nicer Python iterator right now. I just want to get something working. So I'm going to return a list of match objects, which you can still iterate over. It's you know, close enough. For each match, I just need to basically do something like I was doing before, where like for each match, for its named groups, we're going to get a plain name out of it, just substituting away the ending sort of digit stuff, the unique name, and saving that named group for later. I'm also going to do, just for safety, in the match object, when you get a group, we're going to return that, or can I do that or none, or does it key error on me? We will see. I'm going to try to do that. Anyway, so results. So we've got a new match object. So I'm going to say my custom match object is equal to a match, and then custom match is going to have its name groups added, and then we are going to append custom match to our result array, and we're going to return result. So, assuming all that worked, which it probably didn't, down here we're going to first get this match, and then if m exists, if we did in fact match that regular expression tag. Oh, I need a way to get like just the base group. I'm gonna say like, I'm just gonna hard code like if I need named groups actually, and I need string. You know, I need to actually save the text that it matched. That seems important. So if name is actually equal to the number 0, then we're going to return a matched string. This is a total hack. This is not a proper general regular expression group thing, but again, this is experimental. I'm also then, when I actually create one of these match objects, I'm going to, I think I can actually throw the string that it matched into the constructor. So I'm going to do match string, self.matchString equals matched string. So that'll be kept around. And every time I create a match, I can just do m.group0 to get the entire string that it matched. I'm not handling numbered groups except 0 right now. That's the thing. Match.group0. Coming back down here again, if we do match a tag, then we are going to find for arg matches in arg.findIter in, I'm actually going to call this tag match. That's a clear name. So in the entire text of the tag that we matched, we're going to find all the argument matches, and we are going to print all of these things. We are going to print argmatch.group argname. Oh dear. Argmatch.group, what are my things? Quoted value and bare value. And if all goes to plan, what we should see is like quote delix none, post none 1 2 3, foo bar none, baz none none, or something along those lines. What did I say? And that's what we got. Quote delix none, because again, it's the name, the quoted value, the bare value, depending on whether it was quoted or not. Quote delix, post was bare, so it's post none 1 2 3. Bar was quoted, so foo bar none, and then baz had neither value, so it's baz none none. That worked. What do you know? It worked. Well, hey, that's pretty sweet. So we managed to accomplish a system that, you know, an incomplete work in progress system that lets you create regular expressions with a nice sort of DSL, a nice format that's sort of self-documenting, that supports names and back references, that lets you arbitrarily compose other regular expressions into them, preserving names and back references, and then provides an interface similar to the one built into Python that lets you match this against arbitrary strings and get stuff back exactly as you would hope. And it's actually working. It produces some wild regular expressions. After all, like there's an enormous amount of redundant anonymous groups in here. You see so many of these, like paren, question mark, colon, which creates a group in Python's regular expression thing that doesn't really affect anything. It doesn't affect the numbering of groups. It doesn't affect anything except that it groups things and isolates them so that question marks and pluses and whatever work as expected. There's a ton of those because for every wrapper instance that I have, it actually generates another anonymous group just to be safe. A lot of that could probably be pruned, but like it doesn't have to be for this system to work. And like, you know, if this were going into like a full production thing and you'd be building some really big, complicated regular expressions, yeah, we'd probably want to cut out a lot of that bloat because there's a lot of bloat. But for this, totally don't need to worry about it. I'm very pleased. It actually does the thing I wanted it to do. That is super fun. With that, it is after midnight here. I do have to work tomorrow. So I'm going to have to call the stream here. This was really fun. I am so pleased that I actually was able to get through to the end of the problem at hand at some point. Tell you what, let me commit this. Let's initialize this. Didn't know what to call this at first. So it was called, a friend of mine suggested exquisite regular expressions, and so as a joke I named it Exquex. Impossible to say and impossible to type. You try typing. Take a look at your keyboard and see how you would type EXQEX. It's just horrendous. I'll name it another time. This commit is going to be build a system which enables you to arbitrarily compose regular expressions. I don't care, Git. That's a commit that deserves a long name. All right. Thanks so much for hanging out, everybody. This is a lot of fun. I learned a lot about Python thanks to Userman, who I think must have signed off a while ago. Bye, Userman. Userman and other people who were chatting, teaching me about generator functions, helping me discover that my understanding of Python's class system was totally wrong, talking about grammar levels and all that kind of thing. This was a really great time. Thanks so much to everybody who showed up and hung out. I hope to be doing this again soon. And actually, I know the game won't be released for a while. I did pre-order Exapunks, the new Zachtronics game. So that is going to be a great time when that comes out. I'm definitely going to be streaming that. But I'll be doing other programming stuff too. Don't know what it'll be. Maybe it'll be other one-off sort of experimental projects like this. Maybe it'll be some of the other stream projects that I've worked on. But I hope to see you all there next time. Feel free to follow. It's follow on Twitch. Feel free to follow if you want to be notified when I go live again. I don't have a firm schedule, but ooh, a Haskell learning stream. Oh, that. Ooh. Yeah. That would be something. I might have to do that. That's a very good suggestion. But you have to be there. You're the one who suggested it. You have to show up. All right. Anyway, thanks so much. See you all next time. And goodbye.